Okay, hi, good afternoon. Good afternoon, everyone. Welcome to the course for lesson 1 for DS102, right? Now, I'll be your trainer for this course. And my name is Fan Ying Lun. Fan is my surname. I'll spell it out in the chat. Okay, Ying Lun is my given name. Okay, so again, welcome, welcome everyone. I believe I should have about 9 of you. So far, I only see, I think only 7, right? Okay, nevertheless, let's start. So if you're already here, right, please at least enable a camera. So give me a indication, right? So I know you're here. That'll be helpful, huh? Thank you very much. Hello, hello. Okay, how about Jianwen, JY, Jia Ming, you're all here? Okay lah. Okay, good. Looks like a good portion of you are here. Okay, so welcome. Now, first thing first, this is the IBF funded course. They always need you to show proof that you're here, right? So you need to sign in for attendance, So key thing is make sure you're able to access here. I'll put up the link, I'm not too sure whether all of you have attended DS101 before, because I think not all of you may have. So if you have not, right, or if you have, anyway, just click on the link I put up in the chat. Make sure you can log in, make sure you log into the link, able to access DS102, and then provide your attendance sign in, right? So I'll show you what roughly it looks like, if this is the first time you're using the Hackwagon learning portal, So I hope you can see my screen, So hold on, give me a minute. If anything wrong, just give me a shout, If suddenly I very quiet, and it seems I'm talking, I may have muted myself or I didn't share my screen or things like that. Do let me know, Sometimes I forget. Okay, okay, there you go, So if you are able to access it, right, with the correct login access, you should be able to see, probably right from the side, you should be able to see this. If not, at least go to the lessons here, on the left hand side, you have menu, right? Let me make bigger. Go lesson, week 1, then you should still see this. And right at the bottom here, right, you should see a sign in page. Okay, do sign in now, to show the proof that you have just signed in to join the lesson. And then at the end of lesson, which is 5 p.m., right? 5 p.m. we end, then do remember to sign out. Okay, don't leave it alone. Do remember to sign in and then sign out. So it show proof that you are here in the duration of the 3-hour lesson. Okay, so can I have a number, right? Well, okay, can I have an idea that are you able to do this so far? Anyone not able to log into Hackwagon Learning Portal? Anyone? Okay, I assume all of you can log in. Then number 2, anyone? Okay, good, thanks. Anyone cannot sign in to mark your own attendance? Anyone not able to? To give me a shout, put in the chat, Okay, very good, thank you. I think you're all okay, Okay, good. The reason why I'm asking because we had a bit of hoo-ha this morning for DS101. Okay, good. Seems like you guys are okay. Maybe because you've done this before, plus your account is set up properly. Marvelous. Okay, so now because today is the day 1, right? Of the, I think this is also a 7-lesson course, right? Yeah. So I'll be on lesson 1 today. Okay. So lesson 1 primary agenda is all about NumPy library functions and pandas library package, and mostly how to use it to do basic data wrangling kind of techniques. Okay, mostly my focus is on pandas. NumPy, I'll touch it lightly. Okay, although you do have 2 files, right? Your 2 files will be let's see, these 2 files, lesson 1A, lesson 1B, right? So 1A will cover NumPy, but I will just touch base it just a little bit. But it's the lesson 1B that's more important because this is the one that do all the heavy lifting for you, to perform wrangling, pre-processing, exploration, things like that are super important for your journey of data analytics and of course machine learning. So I'll bring more focus to this part, 1B, pandas. Now, so firstly, do make sure you have downloaded these files, right? But key thing is this, you also need to download your data set. So there are about 5 here, I believe 2 or 3 of which we will use it in the example, greatly. Then for me, right, what I did was your standard files that you download, right? These two are your Jupyter notebooks, containing the part of the lesson, right? It doesn't come filled with codes completely. So in order to save some time, I uploaded the complete version. So do download these two. This is the file I'm going to use to carry on the lesson with. Okay, so do download both this lesson 1A, 1B, which has a word completed at the end, of course. I fill up the rest of the cells for you anyway, right? So it's at the last tab here. So download this file. My best suggestion is that put these two files, right? The one that is completed notebooks, right? These two files put together in the same place you save your data set. Because when we use these two, especially the pandas example, we'll be reading in some of this data set. It'll be easier to place them in the same place. Then you don't have to struggle with the folders. Cannot download Anaconda. Okay, Yao Ming, right? Okay, don't worry. Anaconda, I'll come back to you. Give me a moment. Yes, I uploaded. Can you see my screen? It's right here. It's under this tab. I don't know how to change the name. Like you have lesson 1, data set, not categorized, under this tab. This is a completed code. Use these two. You can find it. Adnan, right? Can you find these two files? If not, I'll upload in the Zoom chat also. Let me know whether can find it. Still searching. Okay, I'll upload in the Zoom now. Hold on. I upload in the Zoom. Fortunately, got Zoom. Okay, very good. This is not 101. Yours is 102. 102 right here. Okay, I'll upload one file first. Second file. Okay, I upload in Zoom also. Hopefully, you can also use that instead, Okay. Good. So my suggestion is put these two files together in the same folder where you save all this data set. Okay. So later on we open these files, it'll be easier, right? Okay. Place them together with these employee CSV file, wines 1, 2, 3, things like that. Place them together with these two files, Okay. So now file setter, let's worry about the program you need, So I suppose most of you already have your Anaconda set up, right? So for those who have not, now that will be who just now? Yao Ming. Okay, Yao Ming, right? When you say you cannot download, can you let me know what do you mean by cannot download? Were you here at the website? Were you able to download a file? Were you able to run a program? Where is it that you cannot download? Yao Ming, can you hear me? Unable to run. Okay, so again, be more specific. Unable to run the installation program, or install it, cannot find where to run it, cannot launch a program. What's the problem here? Is it cannot run the installation?
Cannot launch.
Yeah, launch what? The program?
Yes.
Oh, so you have installed it successfully.
No, didn't install successfully.
Okay, so you did not install, but you were able to download the installation program?
Cannot, unable to. This error.
Oh, okay, sure. Okay, how about this? I'll stop my sharing. Can you share yours, please? So I can take a look, on your end. How does it work, Interesting. Can't even download. Okay.
You disable screening.
Oh, I have. Okay, let me enable it back. Let's see. It should be, I think, this one.
Disable screening.
Who can start with some? Okay, you try now. See whether you can share.
Yes.
Can I? Okay, go ahead, please. We'll take a quick look.
Click download first.
Yours is Windows, right? Okay, yeah. Go ahead. Okay.
Then go to one.
Actually, it's still trying, but somehow didn't happen. Okay, then I share you with you another link. Hold on, this Anaconda. Okay, and there's another link lah. Let's try this link. Where are you? Okay, see whether this one look better. I'll put in the chat now. So click on that. Then the download button is somewhere on the right hand side. Try the big green button called download. Does that work better for you? Ah,
A few minutes.
sorry, come again.
The download take a few minutes.
So it's downloading this time.
Download take a few minutes.
Okay, so key is it is downloading something. It is, okay, good, good. Then okay, have you used Anaconda before?
Not remember.
Not really. Oh, you can't remember where to use it before. Okay, it looks like that. Looks like that. If I share my screen first, I share my screen first. Give me a minute. Okay, your Anaconda, if you manage to install and launch it later on as a program, it should look like that. Have you seen this before? Yami, can you hear me?
I think so. But I think
So Yami, I think your connection is not too good. How about you type in the chat? So I can see. Oh, you see it before. Okay, see is one thing. Have you used it before to learn something? That's more important. Have you used it to learn Python? You have, okay. So interesting. Then you might have this installed on your machine. Do you know whether you still have it? If you still have it, no need to reinstall it. You have to wait a few minutes. Can you recall you still have it? Or you need to reinstall? Okay, fair. Then this will take a while. So is it still downloading? Is it still downloading? Huh, okay. Okay, your message is very confused. So I think you're saying that what you have before cannot run. What you're downloading is still downloading. Are you answering two different things?
yes. Yeah.
Okay, cool,
It's
cool.
still downloading, and then when I first open, cannot.
Huh? Sorry, now I'm very confused. Are you still downloading or you have downloaded?
When I first open this, I need to download again because I think corrupted.
Okay, that's not promising, because I wouldn't know what happened before, right? So it's very difficult to tell when you re-download again, will it still be a problem again, right? So maybe the root cause is not whether can download or not, is something else, right? Okay. Now I cannot afford to hold up the class while you're downloading, So how soon do you think the download may work for you? Can you tell? Is it possible to tell?
Finish already.
Finish.
Finish
Okay.
already.
So can you run it to install it?
I click then. Yes, I click run already. I click run already.
Okay. Can you share your screen again? I need to see your screen, no? It's not easy to
Okay.
troubleshoot this way, Can you share your screens once more? I'm okay with you guys stepping away for a short while, but do say come back.
I encountered this problem.
So yeah, wait for me, please. For the rest of the class, right? You guys can step away for 10 minutes.
This one.
Can you hold on first? Hold on first. Let me speak. Hold on first. Rest of class, listen. You can step away for 10 minutes break, Come back at about 2:25, 2:30, We'll see how it goes,
My one cannot,
Okay.
because when I click this, I click next. This one.
Okay, Yami, hold on. Can you don't click anything first, Wait for me, Wait for me. Okay. Now it says that yaoming.ipython. The word ipython, is it what you type or it was already given?
Already given.
That's very unusual. We normally don't have ipython this way. Can you did you choose the path yourself?
I didn't. It was just
Okay, can you click back? Can you click back? Just back. Back some more. I don't see if there are anything else prompt. Okay. Now click agree once. Agree. Then next. Next. You see, normally this is the default. It wouldn't have gone to IPython. So it's very odd that it went there. Okay. So now click next and see how far you can go. Like I say, you installed before. Okay. We'll try a side different folder. So click OK first. In fact, this is not a good idea. Hold on, don't do anything first. Anaconda is a very clumsy program. If we install separately, you might have issues also. It will be better to fix your current problem first. It's going to be a bit messy. Okay, cancel first. Let me remove everything for you first. Yeah, cancel. Yes. Hey, why do you unshare? Can you share your screen once more? Yeah, so I can help you. Can you share the screen, please? Okay, hold on. I will be requesting for access to your computer so I can troubleshoot for you faster. Are you okay with that?
Okay.
Okay, let me request. Okay, can you grant me the access?
Click approve.
Yeah, correct. Let me move my mouse. Okay, I think I'm there now. Are you sharing? I'm afraid you didn't share.
I got share.
No, you only share the web. You need to share the whole screen. Then I can control a lot of other things. Right. So can you reshare? Share the whole screen, not just an app. A whole screen. Then I can control, start button, everything, right? Can you share the whole screen?
This one?
I don't think this is still the whole screen. You can choose on to share an individual application. You must share the whole screen. There's an option to share the whole desktop screen.
Okay, ready?
No, it's still coming up. Yes. Doesn't look like you have shared the screen. Oh, wait a second. It does. Okay, it does all that. Okay, I'm going to request again. So please grant the access. Okay, you're granted, right? Okay, thank you very much. Okay, now let's see. Let's focus on your. Oh, I'm not. Is this Windows 10 or 11? I think it's Windows 10, right? Okay. Okay, very good. Let's encounter. Okay, so you do have it installed. So you're saying this doesn't work?
Yes.
Okay, let me run. Let me try. See whether it still works or not. Let's see whether any error messages. Okay, seems to be running. You got a Conda running. It seems to be running.
Very slow, not responding.
Slow is normal, and the Conda is never meant to be fast. It's possible. No, it's still running. Actually, it's actually working. The fact that you see all these terminal windows showing up is a good sign. There, the donut is coming up. That's the brand. So I think it's working. Let's see how far you can go. These are good sign. Okay, looking good. You're actually progressing, right? Loading environment even. It's almost there. Just need to see the final dashboard. I think it's somewhere there, but haven't shown up yet. Okay, so I think it's just finished. Let me see. There, it can run. Right? It is a big, clumsy, slow program. Just remember that. It's not going to be fantastic, but it will work. You have to be patient with it, right? When you see all these black boxes turning up, the progressing bar keeps saying loading things, loading that, is working. So what you just need now to do is to launch the this one, this guy.
Okay.
So you just need to launch this. Okay. Hey, let's click this launch. Okay. So I'll stop my sharing here. So you just need to launch in Super Notebook. So you're actually good to go. No need to install. Okay. Can okay, marvelous. Okay, now the rest of class. Are you guys still here? Can you on your camera so at least I know all of you are back, or if not, we just have to wait till 2:25. Is everyone back? Okay, I think most of you are back. How about Jia Ming, Jia Wen, JY? If you are back and you, oh, okay, JY, I can see your message. How about Jia Wen? Okay, you're here, Jia Ming, okay, good, all back. Thank you very much. Thank you for being patient with us. Okay, come, let me reshare my screen, huh? Okay, now.
Still be slow. Still be slow. I already click on the launch that
Okay,
notebook. Still very slow.
listen carefully, this is a very slow program. And if your PC is a bit older, and especially now we are using Zoom, your application like Anaconda and Zoom Notebook will be slow. Don't keep launching it. You're only making the matter worse. But you end up launching multiple copies, which might slow it down even further. Launch it once, be patient with it. You will see the Zoom Notebook flash a few black square, and then you will see the notebook program show as a tab on your browser, on your internet browser, right? So eventually you should see that, which in fact what is I'm going to ask everyone to do, right? So for the rest of you, do go ahead and do that also, launch your Jupyter Notebook program by clicking on launch button, right? It can be slow on your end, but eventually you will see the program showing up like that. So maybe I close mine first, so that I get emulate how we begin from the start. Okay, so if I launch it now, you'll see it's trying to launch. It take a while. It's not a very fantastic program also. So mine can be a bit faster because I got slightly faster machine. But nevertheless, for some of you, it may take much longer, a few more seconds. Eventually, you see the main program show up your Jupyter Notebook. Okay. So now my question is, have most of you managed to launch this successfully? Never mind the folders here first. Key thing is you have a tab that says Jupyter with an orange logo here. Anyone can load this? Looks like most of you can. How about Yao Ming? Are you able to see this eventually?
Yes.
Okay, can okay, good. Now for everyone, right? Once you have this, all you have to do is to navigate to the folder where you download the files just now. The files that I mentioned earlier on, this one. Okay, your data set together with these two files. Go to the folder where you saw these files. Okay, we'll open 1A to begin. These two files plus your data set. Remember where is a folder. For me, it's always somewhere inside documents, multiple levels further down. Okay, so I will take a while to look for it. And for you, go ahead, look for where your files is saved. And mine is all the way here. Okay, so just navigate until you are there. So I'm right here now. Okay, once you.
It was I think suddenly I need to anything suddenly clash again.
Sorry, Yami, can you be clearer? What did you just say?
Suddenly when I click on the thing, it shows this cannot reach the page. Can you take over my screen?
Okay. Can you share your screen once more?
I don't know why I got this message.
Can you close this? Can you close this? Yeah. No, close it. Close it. Yeah. Can you relaunch? Yeah. Just close it. Close the tab. Can you relaunch the notebook once more?
Yeah. Launch. Let me click on launch now.
Yes. One time can already. Just launch it one time.
I click one time only. I never keep on clicking more than one time. Then nothing happens.
Again, don't click on multiple times. You end up running multiple copies. It only will slow it down. So, in fact, if you have already done that, you might have multiple copies running already. So can you reshare a screen such that I can see the whole screen? Because you only share just the Internet Explorer at the moment. I cannot see everything else.
Okay.
Can you reshare the whole screen? Yeah.
Share the whole screen.
Okay. Let me take control again. I
Can.
want to check a few
Okay.
things. Okay, can you approve that? Okay, thank you. Give me a minute. Oh, some of that didn't work. Okay, it still works. Okay. Wow. Quite slow. I can't scroll down. Oh, wait. Can I scroll down? I'm trying to scroll down to the background process. I'm having a problem. Quite slow. I can't even access it. Okay. Tell you what, I release my control. You try to scroll up and down. Can you help me to scroll down? Yeah. Okay, at least you can. Okay. The background processors, right? Scroll down until you can see things that start with the letter P. We are looking for Python. So just scroll down until you can see Python. Oh, there's only one. Okay, wait. Okay, no, don't do anything to it first. There's only one, Okay, close the task manager, just close it. And then let's try another way. You go back to your Anaconda, open the, click on the green icon at the bottom, Anaconda. Yeah, okay, close this program. Just close the program, yes. Yes, to quick. Now we launch it a slightly different way. So you click on the start button on your Windows. Yeah, the Windows icon. Go to the Anaconda folder, expand it. Yeah, expand this one. Okay, scroll down a bit more. So you can see something called Turbulent Notebook. There, that one, there. Click on this one. It will launch it on its own. So don't close this box. You need this box. Okay, leave it alone. Now it will launch Turbulent Notebook. Okay, now try again, see where you can navigate to where you save your files. Minimum should be able to open your files. Yeah, just click until where you save your documents. So where do you save it? Very good. You put them all together, right? Okay, is your data set also in the same place? Yeah, I mean, is your data set also here? I hope you have kept the same place, right? Okay, I think you're good now.
Haven't downloaded.
Okay, download them, put in the same place, later on we use them. Now at least you can launch the notebook, right? This way, I will launch it directly. We bypass Anaconda.
Just click download.
Yeah, but more importantly, go to data set. We need a data set. The rest of this you can download after the lesson. All 5 of them.
Click on download for all the
Yes,
5.
correct. Download all 5 of them and then save it into the same place just now. Okay, remember to move them to the same place. Okay. So I'll stop with sharing first. Okay, good. So now let me reshare my screen, everyone. Okay. Now,
this is how long ago this is?
So what do you mean? How long ago? So Yami, what's your question again?
When I click on download the data for the employees 1K, I saw this thing.
Okay, never mind. I go upload directly in the Zoom. Just give me a minute. Forget about the website. I'll upload in the Zoom.
The CSV is it Microsoft Excel?
Don't worry about it. I'll upload in the Zoom chat. Just download from Zoom chat, please.
Okay.
Okay, there are 5 files altogether. Okay, so download all of them from Zoom chat. Then remember to move them into the same place as you can see all your just now all your notebooks and everything. Save
Okay.
these 5 files same place. Okay, exactly the same place.
Where's the downloads?
So it's very difficult to hear you.
It's very because I really can't find. I have difficulty finding the files, the location. I cannot remember where I put my
Okay.
things.
Then your Jupyter notebook will indicate where is it. So look at the Jupyter notebook at the top. You will see, like for example, mine, right? You see, my
Download.
path is there. Use this to help you. Mine start with documents and second level, third level. No, I have a path there. Same thing for you.
Okay.
Use this to help you. Then just now those 5 files placed in the same place as like for mine is right here. Placed in the same folder. You got that?
But that just seem like one come back.
So again, I can't hear you clearly. What did you just say?
I cannot find where I put my thing.
Okay. Can you share your screen once more?
Sure. I tried to share my screen. Okay.
Yeah. So I can see, share the whole screen so I can see currently where your files. Then we'll move them together. Okay.
Okay. I cannot locate the. I download some CSV, cannot find under the downloads.
Can you scroll this all the way to the top so I can see where is this? All the way to the top.
All the way to the top.
Yours is in downloads. So just now the files you download from the Zoom chat, it should be sitting here. One of the files is called employee. Can you see whether you have an employee file? Start with letter E.
Don't have at all.
Okay. Can you now go to your Windows Explorer? Let's take a quick look.
This one.
Windows Explorer. Windows Explorer. Windows Explorer. You know your file program, Windows Explorer?
File Explorer is it?
Okay. So it's called File Explorer. Okay. So now can you double click on the download? Let's see whether is it there. Interesting. You have not downloaded here.
Message.
Can you? I have no idea where do you download. Can you click on the download button on the left hand side? On your left hand side, there's a word download also. The left hand side, left hand side.
Yeah.
On the left, no, not this. It's not left. Left. Yes. Yes. Same, huh? I think your default download is somewhere else. That's a problem. Can you click on the documents folder? Yeah, document. Can you scroll down somewhat, see whether you got all those files?
No, it's here. It goes to here. It's very not fun. Cannot remember. Very bad, man. Very bad
Okay.
memory locating.
Okay. Never mind. That's something you need to resolve on your own separately. I suggest you copy all these files over. So copy the employees. Okay. Do a multiple select. You need employee. You need your HWA pandas. HWA pandas.
Okay.
It should be here also. You didn't have HWA pandas.
Yes. Okay. Yeah, this is the place. Okay, well, very confusing.
Okay, so you need these 2 files and all the Y123. Copy them into the download folder. Okay?
Okay.
Can you know where is the source, where's the destination, right? Are you okay now? Copy the employee, HWA pandas, and Y123. All 5 files copy to your download folder, please.
Y123 copy and then put in downloads.
Yes. It seems like that's where your main area is. So you just paste it somewhere here. Just paste it.
Under the today here.
Just up to you. Just no, exactly here. Exactly here. Yeah, just paste. Okay, so just now those 2 files also, have you copied over already?
Employees
and HWA pandas.
HWF and that. Okay, sorry.
Okay, now to double check, you go back to your Jupyter Notebook program. Go back to your Jupyter Notebook program. Jupyter Notebook. Does it show up now? Do you see employee? It start with E.
Yes, sorry.
Okay, good. Then I think
must go very down.
it's all right. It's good enough for us. Okay, come. I'm going to unshare. So I think you are also ready now. Okay.
Sorry for causing the whole class delay because of my computer got a lot of issue.
Okay, no worries. At least now we are all on the same page. Okay, come. Let me continue where I left off. So like I say, today we'll be learning about how to use NumPy, but more heavily how to use pandas, pandas to perform things like data wrangling, processing, and stuff like that. Right? Fundamentally, we want to learn how to use it. But I think you'll be learning a bit more down the path in lesson. Actually, no, lesson 2 you're covering web scraping. So I guess today is the main lesson. Okay, so we're good enough. Never mind. I'll teach you all the ropes about it. Okay, so we're outside. Okay. So let's launch the very first notebook, right? Hackwagon Academy DS102 Lesson 1A. Lesson 1A. It's literally just a very brief, simple introduction to the NumPy program. Okay, I'm going to click on this to open the file. Oh, too slow. Okay. Hope all of you are able to see the same thing. You should see a file like that. Clearly saying that Hackwagon.
Yeah.
Okay. You don't have to let me know every time. Okay. Do mute yourself for now. Okay. So okay. Now, so once you're able to see this, right, then you're more or less close. Now I suggest that the very first code cell that you see, mine is like that because I changed already. You will see something like this. Don't run it. Do not run it, right? Just comment it out, okay? So that as a reminder, don't run it. Your Anaconda already have installed NumPy and other libraries that we need to use in this course. No need to reinstall it, right? Reinstall it may even cause more problem. Okay, don't run it. Put a pound sign in front to comment it out. Okay, that's the first thing you need to do first. Now, I would likely not use the cells below. It will take too much time to go through them. What I'll do is that I'll teach you directly from what I'm going to show you now. Brief cursor, brief precursor. This the remaining course, right? You'll be learning about many different I guess technique and library functions that you will be using towards your path to learn about machine learning, right? So along the way, you'll be using let's say NumPy library, which is what we are learning today. We're learning pandas, which is also something you learn today. And you actually cover a bit of web scraping, which normally I will put that aside first. Web scraping is important, but not super important. But it's more important is that you are able to visualize your data, visualize your analysis, your insights, right? So you'll be learning matplotlib. This is more important, matplotlib. And usually this go hand in hand with that Seaborn library. And then finally, I forgot, you guys will be learning machine learning right towards the end, right? So you also learn scikit-learn. Okay, so usually these are the pretty standard 5 in most cases where you learn about machine learning. You need these two guys to help you with managing your data, right? Pre-processing, loading in, that kind of thing. You need these two guys to help you with data visualization techniques. And this one for your most of your heavy lifting on machine learning effort. APIs, no, at least not that I know of. Hold on. Must look at what you have. Oh wait, I didn't put it here. Not that I know of. Let me check. I may remember wrongly. I may mix up all the classes. That would be if you're talking about API, that will come much later in the lesson. Oh, I don't have it here. I have to check somewhere else. Web scraping, I think it's tomorrow. I think it's a lesson 2. You'll be learning, I think, if I'm not wrong, Beautiful Soup and Selenium. Okay, I believe it's tomorrow. Give me a minute. I check the my internal lesson plan. Okay, lesson 2 is, where are you? Lesson 2 is this one. Oh, my bad. Lesson 2 is still pandas. Oh, that means they have changed a little bit. I remember all this wrongly. Okay, lesson 2 still more about pandas, because pandas is a very huge library, huh? So you actually still continue to learn that. Let's see, lesson 3 is lesson 3. Okay, lesson 3. That means next week, next week then you learn web scraping, huh? Next week lesson 3 is web scraping. Let's see, lesson 4 is your data visualization and text mining. Text mining. Text mining likely also won't involve API. Then let's see, lesson 5, you'll be learning. Lesson 5 almost you learn machine learning, right? So I don't think this course teach you API, huh? Although API no need to learn one, is you just need to know how to access a URL and then convert the data, know how to send a request and receive the response, huh? So you could easily Google on that. Okay, huh? No need to really attend lesson in general, huh? Only first 2 lessons involve stats. That'll be a very odd question, huh? When you talk about stats, you have to be clear. When you're talking about the mathematics behind it, or using a tool to get the statistical metrics. What do you mean by learning stats? Yes, we will be using pandas to retrieve statistical metrics numbers, huh? In fact, I'm covering that today. Okay, very basic ones. We're not covering very heavy stats, huh? Okay, so where does web scripting come in? Well, good question. So now, I guess I will cover a bit of that lah, huh? Although this is outside of scope. See, normally your data might very normal cases, your data may be inside a file, maybe it's a text file, CSV file, maybe even Excel file, right? That's standard stuff, right? Most of data for most of our daily work likely is just sitting as an Excel file, huh? But in a bigger company whereby you have RDBMS kind of server running, RDBMS server running, like SQL or Oracle, etc., SAP, or even you have some cloud-based Azure or Google or maybe AWS kind of databases running. You pull your data from a database, right? So you can also have data stored on databases, and also from website. Let's say like Wikipedia, you have a lot of tables, right? Also possible that consider those as your source of data. So many different sources, right? What if it doesn't? Okay, what if it is not any of this, and website wise it's not something that is clean and you can download directly? Then the only way to extract the data that you need from a website, right, which you cannot readily download, you have to use web scraping technique. This is the only time you have to apply this technique, because there's no other way for you to get data sitting right there on the website. So for example, Wikipedia is one of the good example. Some Wikipedia, you have tables and tables of data, right? Is there a button for you to download the table? Likely no. So you have to use coding technique through web scraping library functions to help you to technically manually go to the website, go to the HTML codes, find where a certain location or where the data might be, and then slowly crawl towards that location, and slowly line by line, code by code, bring it down and decode it, split it up, clean it up, just to pull the data that you need. A lot of heavy work, very painful, but end of the day, was the only way we can get the data. So web scraping is a lot of manual work, a lot of patience, a lot of investigative work. Okay, it's the only time you do that if we have no other options. You cannot do a website download directly, things like that. Okay, so web scraping is where you apply this kind of tools and technique to do it. Not my cup of tea. I don't like to do web script, very painful. Okay, I hope that answer your question. Okay, cool. Okay, so I have to quickly begin a lesson. You guys only have 3 hours. So let's not waste too much time on this. Okay, where was I? Oh yeah, let me cut this. Before I carry on, right, I do have a practice of using code share. So that if I write any new codes that is not inside your notebook, at least you can copy and paste directly from here. So I put the link to the code share. You don't have to sign an account, it's free. No need to sign in any account. Just copy from here. Say for example, right, you will now immediately see on your side, right? Then you can, if this is a code, you can just highlight and copy. Okay, so it's very common that I use this to share the codes. That'll be easy for everyone. Okay, so come back to here. So let me see. Okay, these are usually the main library packages you will use. in your journey on learning and using and applying, practical machine learning. Okay, so for me, I'll cover these two, the basic stuff today. I think tomorrow my colleague trainer will cover more extensively on pandas. Then eventually you start learning visualization using these packages. And I think your last 3-4 lesson is all about this. So this is the fun part. This is really the best part. But everything here is enough and important for you to manage the data, right? Pre-process and explore the data using visualization analysis technique. Okay, so let's not focus on this. So that's why now reduce to this, right? So for right now, I'm going to first show you this one. Then later on the second lesson, the 1B file will focus on this. So I think, let me see how much time. Okay, so I spent maybe 30-40 minutes on this. Then the rest of the time I'll focus on this. This one is super important. You use pandas a lot because pandas is a wonderful library packages, very rich, very robust, very actively supported by the community to make it works very well for us to be able to read in data on scale such that you can look at the data in a very visually friendly manner. Later I show you the differences, you appreciate how well Panda is useful for us. Then for NumPy, is packages usually reserved for working with any arrays of data that can have multiple dimensions. You might be working with a single dimension, 2-dimension, rows and columns, or 3-dimension, right? We call it tensor, right? Row, column, and I don't know what's the third one called. I think height or something, So, or even more, 4, 5, 6-dimension, right? So technically, right, NumPy is useful to work directly with the coding representation of mathematical numbers that are stored in like algebra, vectors, and matrices. So it's very powerful, able to do mathematical operation on algebraic kind of data. So that's what NumPy is very good at that. Right? It's fast, it's very capable of doing that. But for us, we will just learn the very basic of it, because most of the time, most of the heavy lifting work on data management, right, is through pandas. Occasionally, then you squeeze in some NumPy to help you out a bit. This is more like a supporting actor, your main actor, this guy. Okay, so I'll just touch base a little bit on this guy. So let me just shrink it down to this. So for NumPy, right, to use it, we have to import the library. So I hope you still remember how to import libraries, right? Import library, you always use this command, import, then the name of the library. So NumPy, usually is how you import, right? But for NumPy, and even all the other things you'll be learning along the way, somehow in the wild, right, people conventionally use a certain way to import with a very specific conventionally chosen alias. NumPy is always import with this alias, MP. It's very common. You read books, you see website, blogs, discussion board, right? All use it this way. So they don't use it directly. They import the library function as a library package as an alias called MP. So any other command from NumPy, I will use MP dot something to call the function. Okay, so it's by convention. Doesn't mean that you must do it this way. Your choice. You can just call it. Maybe you can call it you can call it anything you want. Okay, simply just import this way. It's your choice. But by convention, most people run this way. Okay, so we just follow convention for now, So import it. I run it. There you go. Import it successfully. Then NumPy, because work with the form of array, right? So array, think of it a bit like the list you learn so far. Or let's say my list, right? My list of numbers is something like, maybe this is your list of number. Then NumPy will be able to work with something like that. Then this will be just a single dimension, right? Just a single row or single column. But NumPy can go further, right? Remember, I say it can work with multiple dimensions. So this is where list is not very capable of managing that easily. I mean, technically you can, if you die also use it, right? You can like, no, I got one row of 3 columns value here, or that a second one, right? Another row of 3 column values here, and we use a nested list to behave as if it's an array. You can. There's no stopping you from doing that, right? So this is still a list with embedded list inside each. Each of the embedded list is representing maybe a different column or different row. You can, right? But it's very difficult to access it, and it's not easy to do the algebra kind of operation on it directly, right? A list doesn't allow you to do that. NumPy can. that makes it very different from something that you do it this way, huh? So if I do it in NumPy, right, the quick and simplest way to represent these numbers here is, let's say I give, maybe I'll call it my array, huh? I'll just use something arbitrary. So it'll be MP array, to create a new array myself. Let's say I start with a simple 1 row of data, and this is enough to start a new array. And this area will have a NumPy array of these 3 values, and it's a single dimension, right? So if you use something like, okay, let's double check. I always do this. Let's double check whether am I using the correct data type. And there you go. This indicate that this is confirm a variable of NumPy array. Okay, at least now we know. And how about how many dimensions are we playing with, right? So just type array dot shape. It will give you the answer. So here means that there are 3 rows. So 3 rows, and that's it. No column. So just actually technically it's 3 columns. Okay, 3 columns, and no rows, right? So you exactly have just like that. That's why if I type it on its own, right, the actual value looks like that, right? This indicates that you have technically 3 columns, right, or 3 rows, depending how you want to orientate yourself. Okay, so it's the most basic understanding of what a NumPy array can look like. So you want to do that 2-dimension, right? Then what you have to do is, there are a couple of ways to do it. I think I can do it this way if I want to. I'm a bit rusty on initializing this way, because I very rarely need to wait. I always accidentally click this. Hold on, Okay, so I believe I can do that. Okay, I'll go put some of this in the code share, so that I can see what I just did. Okay, so I shouldn't use the same name, Okay. Okay lah. Can. Okay, so let's double check whether I put it right, I should see 2 dimensions. There you are. See, 2 rows, of 3 columns, right? So the shape of this should be 2 by 3 lah, There you see, 2 rows, 3 columns. Most of your work, right, you probably hang around about 2 dimensions, because you'll be using a lot of times this guy hand in hand or interchangeably with your pandas. And your pandas is designed to work with 2 dimensions, rows and columns, just like what you see in your Excel file, right? Rows and columns. So when you use interchangeably here and there with NumPy, you probably also work with rows and columns, so 2 dimensions. Unless you are working with numbers that you're going to maybe research in the area of 3-dimensional object moving in the 3D space, that kind of very scientific experimentation, then you might have a bit more dimension here, maybe 2 by 3 by 4, that kind of thing. But most of your future work likely deal with 2-dimensional data. So probably you stop at this point, 2 row by column, okay, or X by Y. So this is just the most basic understanding of how NumPy array may look like. How to initiate just some simple sample to test things out, right? And how to determine whether you're working at NumPy array, you check the data type first, and then also check the shape, right, to make sure that you are pretty sure how much data you're working with. Okay, so I'm going to put some of this inside the code share, let me shift it away. Okay, anyway, any quick question for me so far before I go into a bit more things about the NumPy array? Any quick question for me? Okay. Shape is here, so this is a single dimension. Then for the 2-dimension is this. So I think I should put this also. Okay, when you copy, be careful from the code share, because it's a free version. I can't control who will update it, so don't accidentally overwrite or delete things, okay, so that the rest of classmates able to copy also, Okay, if no question, then let me see what else we can try. Okay, now you can also, of course, do things to it. Let's say, for example, let me replicate a 3rd array, I'll use slightly different numbers with 3rd array, and to make it obvious, I'll put some zeros here and there, so that when we do some mathematical operations, it will be very clear to you. Okay, maybe I put 10 here, mostly 10, or maybe not everything. This 100. Okay, maybe 100 here, 1000. Okay, so I set up two arrays now. One is called my array 2. Okay, the other one is my array 3. Okay, now if you think of this as your vector and matrices, right? Remember, if you high school maths, you learn about algebra, playing with the vectors and all that, right? If this vector add this vector, right, then the outcome will be this one plus this given a new value. This one plus this give you another value, and then you form a new vector that is outcome of all these individual cells summing up themselves. Then that's how you do your max back then, right? So with NumPy array, you can do the same also. So if I use this plus this, the outcome should be exactly what you would expect with a mathematical operation. You see? That's the beauty of NumPy array. You can do things like that. You treat it like a true blue vectors or matrix to do mathematical operation, right? Including other things like minus, multiplication, right? Multiply, even can do dot product, cross product, stuff like that. But we won't go into that, but you definitely can do all those things. Okay, so this is the beauty of it. You can do matrix, mathematical operations directly on it. Okay, so do try it out. I put the operations there. Okay, it's in the code share now. Okay, so this one will work fabulously, right? So even let's say I do let's say this guy, I multiply this guy by maybe another 10. Then every individual component inside the matrix also increase. You see, by 10. Okay, 0, of course 0, all increase by 10. I mean, all multiplied by 10. See, pretty cool, right? So you can do stuff like that, So and in some sense, right, later on when we learn pandas, it also can do all this. Okay, so with NumPy, definitely you can do any kind. I mean, most of the doable kind of matrix calculation, including even dot product, cross product. Okay, but we won't go into that, Now, that's one reason we like it. Now, another thing is that what else on the array itself? Let me think. I think that's pretty much it, because you can use this to perform algebra operation. Hence, especially when it comes to machine learning, right? But in this course, you are not going to be learning that, because there is a lot of explanation on it. When you try to understand basic stuff like how the gradient descent happens, how maybe the forward propagation or back propagation of deep learning model works, right? At that point, we do a lot of calculation. We do a lot of differentiation, that kind of thing. Then there's a lot of interaction between matrices doing mathematical operation over each other. We can depend heavily on NumPy to help us on that. That's why we love to use that at that point, to demonstrate how the math function behind the scene, right? Using codes to represent. Okay, but your course here is not long enough to teach you those things. But you can read on your own elsewhere, seeing how people explain using Python, right, to show you how the maths happen, for things like gradient descent and stuff like that. Okay, so I think this is enough for now. I'll just highlight a bit more about what normally we use NumPy for. For me, right, NumPy very useful for us to say generate randomness. So with NumPy library itself, it has a lot of random number generator, right? It has one for normal kind of numbers that is between a certain range, normally 0 to 1. So you have decimal numbers. It has another one that can generate only integer numbers. It also has one that can generate randomness based on what data you have and choose one of them. So for example, right, you have maybe I should type R. Okay. I think, oh wait, it should be a random. Under a random sub library function, right, you have they have this bunch of random generator. So the most common one you use might be like either this or this. Occasionally you use the integer only, and sometimes I also use this a lot. Choice. Use choice, So choice is one of those handy one. Right. Okay, let me show the random one first, So this is really depend on, maybe I use an integer one. I hope I spell correctly. Let me see what I get. Okay, good. See, so if I put a single number, it will just generate any integer number starting from, I believe, from 0 up to, this part I always forget, either inclusive or not inclusive 10. Okay, so let me make it go through a few times. Let's see what we get. I think integer is inclusive. Oh, sorry, so silly. Oh, not inclusive, I don't think I see it. Let's run a few more times. Okay, start from 0 to 9. Okay, so if you use random to generate only integer numbers, you get about 10 numbers. Right? We start from 0 up to 9. So 10 is not inclusive. Right? The reason why I get confused because one of them is inclusive. Just forgot which one. It's very messy. Okay, I'll put this here. Play around with that. Right? You can also play around with the other randomness generator, but I'm going to show you this one. This one is more interesting. Although sometimes I forget. Let me see the help. This is an array. Size. Okay, come. Let me do it. So this one is interesting. Let's say I have let's consider a die. I have 6 numbers. So you see, this alone can generate as the randomness of choosing one of them as if you're rolling a die. Pretty cool, right? So choice, you can choose exactly what you want it to roll out. In fact, not necessarily must be a number. You can even play with a string or anything, right? Anything you want. As long as something reasonably inside your list is good enough. Red, blue, or green. You see, very useful for randomizing choices of things that are either fixed numbers or not numbers. Hey, did I make some mistake? Why it keep coming out green? I made a mistake. No wonder. There you go. Okay. Pretty cool, right? Okay. So try it out. Choices is one of those things I like to use that come from NumPy. Very handy. Okay. There you go. So the random generator is very useful. It comes from NumPy. So this is where we use it a lot. Then the other things that also some sort of generator which also use a lot is when I like to generate a array of numbers that I know start from 0 to something, or maybe any number start from 1 to something, and I want exactly 10 equal parts of it, that kind of thing, right? So you want you can ask for 2 types, either consider linear distance between each of the 10 parts or logistically kind of distances, right? So very handy for you to experiment with things later on with machine learning. So for example, NumPy has a lin space to do that. And let's say, let's keep it simple. Let me try 10 first. Sorry, it should be, I think it's starting from how many to where and how many I need. So I say I need 10 of them. So you see, so maybe 10 not too good. Let me, wait, 10 should work. Okay, maybe I start with 1 would make sense. This is the one that is inclusive. Okay, so lin space means linear spacing, right? Meaning that within this range, I want 10 of them. Then they must separate exactly equal distances. So that's what linear space means. So I start from 1 and all the way to 10, inclusive. And I want only 10 of them. So this one, I stick it such that it's nicely come out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I say I want 11 of them, right? You see, you have 11 of them, but they fit exactly within the range 1 to 10 inclusive, and they are all equidistant. So here to the second item is about 1.9. 1.9 to the third item is about 2.8, right? They are all equidistant. Okay, this is linear space. Very handy, right? To also, in a sense, generate a range, but of your own choice. It's almost similar to your, remember you use range to generate some sense of numbers. It's very similar to this, but this one give you an array. This one give you a range object, which is some kind of iterator, right? So for this one to access it, you must use a for loop, things like that, right? This one no need, you can just use it directly because it will return an array. Okay. Then which I forgot to mention something. Never mind. Let's carry on first. So this is another reason why we use NumPy to generate this kind of values, which can use in a lot of places, like maybe even plotting a chart, or you need some arbitrary x-axis value, then you can use this. Okay, then a standard version of this is log space, also very handy. Something we use a lot in our I guess journey of understanding machine learning. So this one means that the value side, let's say you want 10 of them, you'll be going through the number side in a logarithmic curve. It's no longer a straight line. So logarithmic curve means that here, right, it's no longer about starting from 1 to 10. It's starting from the power of 10 to this power to the value of 10 to whatever power here. So it's all about 10 to the something power. So if I put 0, that will be 10 to the power of 0, right? That is 1. All the way to the 10 to the power of, it's too much, 10 to the power of 5, and I want 10 of them. So maybe let me cheat a bit. Let me put, I think maybe 6 should be fine. I see, I asked for exactly only 6, but through a logarithmic kind of spacing. So it's actually a curve, logarithmic curve. So you see, the first one is 10 to the power of 0, right? So it's just 1. Second item is 10 to the power of 1, so it's 10. 10 to the power of 2 is 100, 1,000, 10,000, 100,000, logarithmic scale. So sometimes you want this to visualize, right? Maybe mostly used for visualization, mostly used for maybe choices or parameters that you can fit into your maybe your what's that, machine learning during hyper fine tuning. You will see this used a lot in your hyper fine tuning. So it might be a bit tricky word at the moment. Later you recall that I mentioned this before. Okay, so sometimes we use this also. This is also another common choice. Yes, question.
Can scroll a bit. That's not this part before.
So scroll where?
This one scroll a bit. I think copy down.
I put it in the code share already.
But I need back because
So Yami, I really can't hear clearly. What are you asking me for again? What do you need?
Because my computer a bit slow.
Yes, but most of this code I put in the code share. Just access on the code share.
Okay.
I left it in the code share. Okay. Now I think that's it, Yeah, I left it in the code share. Okay. So now this is usually what I use NumPy for, and what most machine learning practitioner might use NumPy mostly. Apart from some of those things I mentioned earlier on. Okay, now I forgot one thing to show you in my haste. Remember, end of the day, NumPy is an array, right? So let's say for example, I go back to these guys. I go back to the very first one, single array, right? Now I hope you still remember your indexing and slicing technique. You can apply also on your NumPy array, right? The same rules apply. So say I want to pull out the first value, you just use index 0. Okay, so let me sure we know what it is. Okay, so I want to pull out index number the second index, right? 2. The last one is this one, right? And then same idea, like -1 will show you the last one. Now all these rules still apply. So if I print multiple variation, then you see they are all the same. Okay, this one and this one, right? My array 2. Okay, all these indexing technique that you learned before, right? When you learn about string, tuple, list, all this applicable for even NumPy arrays. And then if you apply slicing, right, still the same. So okay, let's say it's very few. Okay, let's say the first 2. See, so it give me 1 and 2, right? I choose the first 2, or maybe I choose the last 2, right? Also can. So the sizing also the same, right? Maybe I go with the last 2. Sorry, should be the other way around. Start with 1 and end with the last character. Okay, there you go, So maybe I put everything nicely together. I'll put this in the code share. So I forgot about this just now. Then even the same with multiple dimension, is still the same behavior, Right? Even with where's my multiple dimension? Okay, maybe my array 2, still the same. Okay, my array 2. Okay, sorry. Okay, this one Okay, this one a bit tricky. That means now you got two parts to it, huh? So let's say let's learn about extracting just one, huh? I'll put it here. My array 2. Okay, maybe I should just print. I don't think it'll mess it up. Okay, so my array 2 looks like that, huh? Okay, just now I do that. Okay, I changed the print in the first example. So okay. Okay, good. So with this one, we can also do the same, but now because you got 2 dimension, right? So you should usually separate with a comma, or let's say I will just want one value, right? This one, how do I access it? Row, column, no? So first row, first column. So I get my 1. Okay, so you want to access this one, right? Will be the second row, right? Row 1, row 2, third column, and they all using index positioning. So start with 0 always, so this will be 2. You get a 6. Okay, so try the various different indexing position to understand how you access it, okay? So just try, just try, so you can get used to it. So this is 0, this is 0, and that will give you the first character. This will give you the last character, things like that. Okay, can share your complete notebook. No, I won't do that because the complete notebook is already there. All these are just working, which I share in the code share. You can easily copy from code share. Okay, so now so if I want to select a range, right, then you have to be very clear where you put, okay? So a range, right, let's say I'm interested in the range of maybe this one, 1, 2. This one will be easy, because it's on the same row. Then all you have to do is, right, if you think logically, all you have to do is okay, first put the comma there. The row 0, so it's the same row, right? Column 1 and 2, right? So column 1 and technically 2, right? But remember, in that sizing technique, you don't include the stopping index, right? So you must put 2. Now this should give me 1 and 2. Okay, there you go. So you want to be fancy, right? Like want to grab only 1, 2, 3, 5, also can. So you just have to slice respectively based on the row and column. So row wise is row 0 to row 1, right? So technically, everything now, in my case, I could just leave it. Oh no, I cannot leave it. I think I must minimum put this there. Minimum I must put that, right? But very, very accurately, it should be starting from row 0 and ends at row 2, not including row 2. Then this will give you the same thing, 1, 2, 3, 5. So that's the correct way to do it technically. But remember, we can do shortcut, right? Default values will fill up the space. Also can. So let's try maybe is there a way to use this? I think my example too simple. Maybe yeah, never mind. I'll stick it like that. In fact, this one also can simplify to this. You still get the same answer. Okay, so try around variation. You will get the respective component that you need through indexing or through sizing technique. Okay, you can even choose maybe just this column also can, maybe add one more through the column. So let's see. Oops, that's bad. Print my array. Let's say I want 4 and 6, right? So row wise there'll be 2 now, so I'm going with both rows, but I want only the third column, right? So 0, 1, 2, so 2, and there you go. See, then but the funny thing is that this one I just did, right? Which 1, 2, 3, 4 here, it'll give you the answer in a single array dimension. Okay, that's how it works. So it'll give you a single array dimension. Okay, so maybe I put here. I'll put back inside. Okay, so through this manner, you can still do your indexing technique. You can still do your sizing technique, right? To retrieve exactly what you want inside here. Of course, they must be continuous and contiguous. You cannot like choose one here, one here. No, cannot, right? You have to have some reasonable reasonable how to put proximity, or you can choose columns, you can choose rows, or you cannot choose like separate ones, you cannot like that. Okay. There you go. So actually, as long as you know your indexing and slicing technique from lists and tuples, this part I think eventually will become quite straightforward for you. Okay. So then of course I think that's pretty much it. So let me see what else did I miss. Okay. In the meantime, you have any question, do feel free to ask me. Let's see. Here is about creation. We did some of this already. It's just checking the type. So we actually cover all this. And then manipulation. I didn't exactly do this. Okay, let me explain this part. With numpy array how do I put this? Unlike list, unlike tuples, you, in fact, if not wrong, right? Let me check. Maybe I'm wrong. Okay, hold on. Let me check. Okay, this one definitely will work. Okay, now even when I mix the case, it will still work. Now, what if I do things like that? I put a string. Okay, it will still work, but the problem is that even though just like list, tuple, things like that, you can have mixed type. Look at that. I have a string, I have a float, I have an integer, right? But usually numpy array will try to how to put it, recognize that the items here are of the same data type. You try your best. The best way to use numpy array and later pandas is to make sure that they are of the same data type. That kind of more makes sense with the way we manage data. So usually it try its best to figure out what might be the common data type. It try its best. So if it cannot, it will not be able to tell very well. But in this case, it's all messed up, right? So if I make it clear that they're all the same data type, then it will be better. Okay, so in fact, it doesn't even mention because it knows what's the basic data type. And because there's a basic data type, right? You can change it from one type to another. This is what the S type is for. So in our example here, right, we created a arbitrary, numpy array of decimal numbers, all 5 of them. We save it to the array here, and we can purposely turn them into integer. So in one shot, change the data type of all of them into integers, which force it to also round the number down or up to integer. That's why if you run this tool, right, this statement here, the original array in floating point, the conversion array, right, where your numbers are round or down in integer values. So you can do that, right? It's not something you do very common, but the opportunity of doing that is there. Okay, so this allow you to convert wholesale all of them one shot to a certain data type. Okay, so this almost seems to reflect the same thing that you can do so far with numpy arrays. You can operate or use certain function, right, to apply at one shot all the elements in your numpy array. It could be per column or per row, but technically you can apply on more than just one item. So that's the best thing on numpy. Okay, so then remember I also show you calculations, right, using it, treating it as matrix. So it's mentioned here. And multiplication also can, things like that. You even can do this. This is even more cooler. Okay, so this part is very important for us. You can even do things like checking, whether something is you're doing some comparison, right? Whether something is equal or greater or equal or smaller, that kind of thing, or not equal with another, and you do it wholesale on the matrix level, like matrix versus matrix, so that if you execute a command like that, what the program do is that you check each cell with the respective cell from the other array and check whether is it, in this case, whether is it greater than. So you're checking this one, is it greater than this one? Not true. This one, oh sorry, y. Okay, so y is here, right? Okay, so this one, is it greater than this one? Yes, right? So the comparison should be true. So you got one answer, true. Then you go to the second cell here. Sorry, here. Is 8 greater than 3? Also true, right? So it also say true. And it keep going on until the last one is this greater than this? This one no, right? So it'll be false. So the result of this is a new array, but the array answer inside, right, the content will be true, false, because the result of this has to be only true or false. But you got a lot of them, right, based on which position in the array we are working with. Hence, this can we further use to figure out other things. So with NumPy, this is good. With pandas, even better. This is the type of check we can use to figure out whether certain data point, right, is within the kind of range you are looking for, and can filter out those that you don't need easily using the true false statement in your function and calculation. Okay, so now it's not too obvious how we can handle it better, but when it comes to the pandas, I'll show you how. Okay, so in NumPy, you can do the same also. Pretty cool stuff. Okay, so if I run it, yeah, there you go. Then let me quickly see what else we have. And then also in NumPy, any areas of numbers, right, you can perform mathematical kind of aggregation and also statistical kind of calculation. Aggregation is like you can do sum, you can also do where's the mean? You can also do mean. So for example, this one is to sum up everything, right? So you can do a NumPy sum, then the array inside. I think you can also do mean, if I remember correctly. It should be the same. Mean. Then you count the averages of these four numbers. Also can. You can also do mean, right? So I'll put that here. Then if you work with multiple dimension, you might like to control. Oh, actually I hardly use display. Why do we use display here? Actually no need. Okay, let me comment out. Wait, let me run this, make sure it works. Okay, interesting, we do a display here. Okay, let's try this instead. You can also choose exactly which whether should it sum up row level wise or column level wise. Yeah, I don't know why we use display. Okay, so you can use this second part of the sum, right, to decide you're going row level or column level. So if it's a 1, it should be 1, usually is column level. Let me see carefully. Yeah, column level. So it's summing up all the columns, right, and give you the total sum. So there should be 3 sum value here, right? And then it will display as another array, just a single dimension, right? If you use 0, it will sum up row wise, row levels, right? So here. So 312 is 6, right? 252 is 9, and so on and so forth. And hence it reduced to just a single dimension. Okay, so you can do stuff like that. Again, with pandas, you can also do it this way, and pandas is even more straightforward. So I think that's pretty much it. What about your uniqueness? We'll learn the one from pandas better. Okay. So that's it. That's a very basic introduction of NumPy. I will now quickly go to pandas shortly. So any quick question for me? Any question for me for regarding all this NumPy arrays, the basic stuff?
Can slow down a bit.
Yes.
Can slow down a bit too fast.
Regarding?
Can slow down a bit.
I can't. I'm sorry to say that because this course is very, very short. So I have to quickly show you most of the important things, right? Else most of you will not be able to pick up the later lesson even. I'm sorry, I cannot slow down any further. So if anything you don't understand, you ask me right now. I try my best to explain. Is there any part you didn't understand? That's why you need me to slow down. You can put in the chat anytime you need me to further explain something, okay? How about the rest? Anything you'd like me to clarify further? Or including the additional stuff that add on that the notebook doesn't have? All good, Okay, nevertheless, as I go through, right, you might suddenly remember something that you haven't formulated a question. You can still post me a question in the chat. I'll try my best to answer you, okay? So I have about 1.5 hours. Okay, let me jump to pandas. I would say pandas is more important for you guys. So please open the second file. Lesson 1B. Okay, super important for you guys. You'll be using this a lot. So it's good that you have a good grasp of it right from the beginning. Okay. So if you open lesson 1B, right? You talk about all these things. I'll just mention briefly at the top first. That I just did. Okay, I'll start with this. This is good. Okay, no, I don't want to start with that. Okay, sorry, I prefer to go with a certain flow with you. Now, with pandas, right? If you realize just now, even though I didn't explicitly say our NumPy, notice that it has its own special collection data type, right? It's known as a NumPy array. It could be 1 dimension, 2 dimension, or multiple dimension, right? So it works with its own self-defined collection data type. Okay. Then with pandas, it also have its own collection data type. Pandas work with 2 main collection data type, even though it has a few more, but these are the 2 main ones you'll be working closely. One is known as a data frame. The other one is simply known as a series. So normally we refer this as if there's a variable name that is a data frame, I'll just say this is a variable that has a data type called pandas data frame. Or I have a variable that stores a series, I'll say that this is a variable that stores data type of pandas series. Okay, but nevertheless, most of the time you will be working very closely on pandas data frame the most, or easily 90% of the time. The remaining 5 or 10% will be with other pandas data type, among which series take out the most. I'll show you what will be the difference between these two. Okay, since we're not covering this, I won't talk about that. Then to import pandas, again, just like NumPy, there's a certain convention. So you import pandas as PD. Okay, this is a convention that everyone use. So I'll put it in the code share, right? Pretty standard. So once you import it this way, right? Any function from pandas will always precede with PD. Just like every NumPy function, I will precede with MP. Okay. So let's say let's see what's the best way to show you. Yeah, show an example of what normally you do with pandas. What's the largest data size? Good question. I honestly don't know, but what I do remember is that it's very scalable, so you can handle hundreds and almost to some extent to 1 million rows of data points. But this really varies from case to case, because when I say million rows, I didn't talk about how many columns. You know what I mean? So the key thing is that as long as your data is within, say, casually, within 100, 300,000 rows, and you have maybe 15, 25 columns of data, pandas can manage. Okay, so this is the kind of some of the sample size I see some of my students when they do a project, roughly that kind of size. Could be as large as that, could be as small as just simply 1,000 rows with maybe 10 columns, no problem. Simple, right? Bolasa, pandas can manage. Up to 100,000, 300,000, 1,000 rows, still normally okay. I haven't seen some people work with 500,000 rows. Of course, at that point, right, you're pushing the limit already. It really also depends heavily on how much RAM and CPU processing power you have, right, so that you can handle it easily. It will be so, yes, sir. The one that asked me, Siski is a lot of data, right? So it'll be pandas, you're pushing the limits of pandas. If you reach that level of size, right, you might like to consider switching to a different data wrangling or management platform already. Pandas, yeah, it will reach a certain limit there. Okay, so alternative to pandas for handle really large data, right? They use different technique to handle pandas, handles the data such that they don't necessarily load everything into computer memory. At any one time, they only load a portion of it, so that it's a very clever, efficient way to give you an illusion that it loads your data by actually using partial of data each time to work with you. So I honestly forgot some of those functions, but you can Google. There are definitely alternatives to pandas designed to scale very high to millions of rows of data, like what you're talking about, 6 gig, that kind of thing. There are other functions, but those are quite different. Although, good thing is that they try to design such that it feel and look like pandas commands. Okay, so look out for those. Maybe that can help you with your 6 GB problem. Okay, so back to this, right? Where was I? So let me read data first. Do something to it. I'll show you what are the things you could learn. What was the data we have? I'm going to use the employee one. Perfect. I'll use this guy. Okay, I'll start with an actual example. So you can appreciate what we can do normally. So DF is a name I'm going to give to read the data in. And read CSV is a common command to read any CSV file. Okay, let me start something simple like that, huh? Let me make sure it works. Okay, good. Usually the first 3 commands I use is this. Later I'll put all this inside the code share, don't worry, huh? This, okay, actually normally more in the correct order, normally you do this first. Check a few rows, check some info, and look at the descriptive statistics of the numbers. So these are the first 3 lines.
Just can scroll a bit.
So what again?
I didn't catch. Can scroll a little bit. Just not stop.
So Yamin, I can't hear you clearly. You are referring to
scroll a bit. Can scroll a little bit first.
scrub?
Scroll.
I'm going to copy this. I'm going to copy this into the code share right now. So you want to copy the codes, right?
Yes.
I'm going to copy it into the code share, right? So just wait for me. I actually just mentioned that I'm going to copy in the code share, huh? So just be patient with me, huh? Okay. In fact, I'm not too sure your code got teach you some of this. Maybe 1 or 2 of them, but not everything. But for my work, right, I will always check all this. This is pretty standard stuff, huh? Most machine learning will do things like that. You'll take a look at the first few lines. You take a look at the basic, properties of the data you brought in. Like for example, our friend, right, Anand, right, Adnan. Then you might have the very large data size here. So now you're aware your data taking too much space. Huh? So this is very helpful if you have very large scale of data, and descriptive statistics is very useful, huh, to see what will be the kind of shape of your distribution of data, stuff like that. Huh? I'll go through some of this in details later. Okay. Then other things I might do, right? Fundamentally, right now I'm just running through some of the things I will do. So don't worry too much about it. Right? I will come back to them. So for example, I might do things like check maybe whether there are any missing data. So is and there is one of the best way to check. And I must add a sum. So this is one way to do a quick check. See, 57 indicate the employer title is missing data in 57 rows. This is pretty standard stuff we use. So I put that, right? Then if there are missing data, then I'll decide what to do later. So some of these things we learn further down. Does it matter where it's stored? It does. Because right now, right, I assume it's stored in the same folder as my Superior Notebook file. That's why I keep asking you guys to put your data file in the same place. If the data file is sitting in a different folder, right, then you have to do the work of saying dot, slash, maybe data set, depending where I put it, right, data set folder slash, that kind of thing. Quite cumbersome, if you place it somewhere else, right? Then you have to make sure you add the path leading to where the file is. So best practice is to save the file in the same place where your notebook is, right? And if that is not allowed, or because you want to manage everything nicely in order, right, then it's fine. Maybe you do have the folder, like here, right? Maybe I have a folder on itself storing all the data. Then you just need to make sure you mention the path to it, okay? So this means default is right here, same place as my notebook. Okay. Now back to this side. So so depending on what I want to do, I may further follow by other steps to clean, to remove the rows with missing data or replace them with some other values. In fact, we'll be learning some of those further down. So I won't go into that right now, right? And other things I might do is I might also what else do I have? Okay, let me see what we have. Info. Do mute yourself if you're not asking question. Like for example, home ownership probably okay. Things like these two. These two are obviously categorical data columns, right? So categorical data columns, I like to know how many unique items are there. So you can use things like DF number of unique first to count how many are there for all these rows. So very interesting. So employee ID, it says there are 1,000 of them, which is very interesting information because remember the shape, you can also use shape here, right? I move the shape up. Sorry, what am I doing? Okay, I know that I have 1,000 rows versus 4 columns. We knew that, So it's NA to show you whether you have missing values. Don't worry, I'll come back to all those things later. I'm just showing very quick tour of what are the things we can do. Okay, I'll revisit some of the important stuff. Just bear with me. So dot shape will give you idea of how many rows or columns, right? And I know there are exactly 1,000 rows. Yet there are exactly 1,000 unique IDs. This says a lot, right? It means that employee ID is unique. There's no repeated values, which it makes sense, huh? Employee ID are those things that are identifier, right? Identities. So it should be exactly 1,000 row of each of them very different values. This gives you some idea, right? However, interesting things is these two, right? Employee titles, right, is the job title of the employee, right? Yes, there are only 1,000 rows, yet you got so many different, different employee title, so many unique ones. So this is a kind of those tricky things whereby the category has too many distinct values. No, this is not very helpful for us, right? Especially when it comes to machine learning, something you will learn later, okay? But however, this is interesting. Home ownership only have exactly 3 distinct values. So now you know that, right? I can even say check out for those distinct values, right? How many what are they? They can use a unique function on just a home ownership to figure that out. So this is one way to do it. I'll teach you how to do the trick here later. This is an important trick you need to learn later. I'll show you that. See, now I know that for the home ownership column, you only have these 3, right? So in other words, for all the cells, it's either own, mortgage, or rent. And it repeat. So I know exactly there are only 3 distinct, we in our jargon, we say there are 3 distinct different classes. Okay, so these are some of those functions I sure use one. Other things I also use, like say, for example, value count, also good to know. Okay, so instead of this, right, you can also use value count. So say for example, right, value, wait, it has to be home. Wait, actually, I can use the whole thing. Value counts. Okay, no, mistake. I should use just one column. So let's say home ownership. Stick it with home ownership. Ownership. See, this is another way to look at data using value counts. Whereby I already know that there are exactly 3 of them, right? But exactly what's the distribution? 1,000 rows. How many of them are owned? How many are mortgage? How many are rent? Value count will tell you that. See, 477 rows are mortgages, so on and so forth. All these are very useful and handy function we can use. So I'll copy all this inside. Okay. So this dot shape, same as the dot shape for NumPy. Tell you the rows and columns. But more importantly, number of unit for the entire data frame, the uniqueness of per column, and the distribution per categorical column. So I think most of these are the things I normally check. There might be others, but I'll leave it for now. Right. So even if you go back and take a look at your data frame, right, which I can use. I can use this, of course, but it show a lot of things. Usually dot head will be good enough. Show you just 5. So you see the data frame, when you take a quick look at it, right, it is so much better than NumPy. Right, were I to use NumPy, I will still have this information, but I miss out this and this. Okay, with data frame, the key difference in terms of the display is that you can see the auto-generated index numbers and the nicely arranged column header. NumPy can't do this. NumPy will give you the auto-generated numbers, but it won't show you like that also. It's just transparent to you. It's right there. You can use it, but you don't see it show up. Pandas will display this. And Pandas will display the column header also. You'll figure this out when you read the file. Or in our case, you read the file from here. This simple command take care of a lot of things. A lot of default setting inside. Just that the default setting will be enough to work with most CSV files or comma separated files. So if I look at this file directly, right? If you take a quick look, you see, usually your comma separated files, usually first row will be the column header, right? Then everything else are your data. And because it's comma separated, so everything is separated by a comma per row. So this data command will know how to take care of all those things and bring it in correctly for you and create a new data frame. Remember the data frame object I talked about, right? This is a data frame object. In this case, I'm seeing the first 5 rows. That's what all data frame is about. Okay. So let me see. Did I copy the last one for you? Okay, I did. Okay. So in essence, right? In essence, most of the time when you further down the path, when you start really almost starting to do some more challenging data set kind of machine learning stuff, right? Or maybe your project, you probably will be reading your file from a single file like that. Very likely it's a CSV file. So likely you'll be using this kind of command right at the first few cells. And then when you do it this way, this thing does 2 things. It will open up this file and read in row by row and figure out where's the column header and separate comma by comma where per row where are the data, and then convert and save it as a data frame object to this name here. Right, this is just a name I provide. This could be my anything, my table, anything. It's just a name. Okay. So common practice, we just put DF for data frame. So this one simple command, read in the data for you, prepare and can convert it into a okay, maybe a whole type and save it to a new pandas data frame. Okay, data frame object. So this is what you do. So it really keep things simple for you, right? All I have to do is now continue using this to check a few things here, get all the information you want to understand what is it about, and then even manipulate and change it to something else you want, right? Things that I didn't show you here. Most of these are just exploratory kind of data analysis done. Okay. So I think with this you have a better idea what we do. One more thing to show you, right? Now, if I were to check what's the data type, right? Obviously it's going to say data frame. There you go, it's a data frame. Now, where then the series come in? Right, now you kind of have an idea that data frame is all about a 2-dimensional matrix, which have rows and columns, whereby it also keep track of auto-generated index number for you for the row, and it automatically pick up the column header and give you a column names. So you can use this and this to refer what is inside. We can apply the same idea we learned just now about indexing and sizing on it. Right, I'll show you the pandas way to do it. And this whole thing is a data frame, right? And it carries with it a lot of functions to check certain aspect of it, certain properties of a data of the data inside. Like all these are function is carried on this, right? All these things, see, all these are carried on it, right? All this, So this is a data frame. It has almost nearly hundreds of different functions to work on it. Where did the series go, right? It's actually right there. Every column technically can become a pandas series. Pandas series is only 1 dimension. Pandas data frame is always 2 dimension. So how to then get the series is very easy. So maybe let's do this. Employee. Yeah, maybe I choose something else. Home ownership. I'm going to save the home ownership column, right? To a variable, and I'll show you what is it. Okay. DF. I haven't taught you how to do this, but later on I'll teach you about this part. Okay. If I assign this whole column, right? This whole column to a new variable, I can use this new variable to do something to it also. It also have its own bunch of functions to work with it. And technically, this is a series. Right? If I run this, I check what is the new variable I just created, right? What kind of data type am I working with? It's actually a pandas series now. Pandas series is always 1 dimension. Usually you work close in hand with a column from your existing data frame. Usually I don't even bother to save it as a name. I'll use this part directly on the fly. Sorry. Say for example, right? You guys see me using that just now here? This is a series. I was playing around with a column. This is also a series, right? So any column that I lift out from the existing data frame, that is a series. A series carries its own properties, its own set of functions, but most of the time it's very similar to the one you can apply already on the data frame. Understand? Huh? So in your own work, right, going forward, likely you don't work on series directly. You probably work on it on the fly, like what I did here. Huh? Right. But it's good to know that when you are working like that, this one column technically is a pandas series object. It's good to know that, huh? Okay. Then pandas series object allow you to do a dot value counts, huh? Allow you to do a dot unique. I think this one can apply on the data frame, but this one no. So certain function can only be used on a series, or in this case, the whole column. Okay, that's all. Right. So I find it very odd that normally in most lesson, right, people will start off with explaining what is series, what can you do with it, then start explaining to you what is the data frame, what can you do with it. But in real life, we don't care about series much. We care more about the data frame a lot, and then we break down into the different columns and work with it individually for different reasons. Then we worry about the series level, right? So I rather start the other way around. Okay, I hope this helps you to understand the concept and usage of pandas better. Now I'll dive in further into what we have in at the bottom. Okay, so any quick question for me before I dive into the actual notes we have here? Any quick question for me? Maybe I share that one with you. So yeah, share this three part. So that you have an idea, a very crisp idea. When do you see a data frame? When do you see this series? Okay, let me okay, like that. And also I want to print the shape, DF shape. Okay, that's one. Then here also print the shape. Home ownership. Okay, so you know which is the 2-dimension, which is see 1-dimension, 2-dimension, row columns. Series is always single
This one
dimension.
can copy in,
Yes, I'm going to do that now.
into the code share.
Yeah, doing that now. Okay, there you go, Okay, let me separate a bit. Okay, done, Okay, there you go.
It's from line it's line 70 to 75, right?
I don't have line 17.
I mean,
I copy this already. This is enough.
70 to 75.
I have it. Okay, okay. Now, yes. Is there? I put it in the code share, Okay. Now, let's look at what we have here, So, like I say, most lessons always start with a series, right? Although in real life you don't really work on the series directly, But example is the, I guess, the best way to start learning it now. Okay, so we load the libraries, so you can run it again, doesn't matter. Then we have a simple list, right? And we create a series using this list. So usually creating a new series, new data frame, you can use this and dictionary combination to help you. So in our example, we show you a few different combinations to do that. But in actual life, your data already going to come from somewhere else, right? Like maybe a CSV file, Excel file, SQL Server, and very unlikely you end up doing things like that, But it's good to know that you can do it, okay, So the correct way to create a series from the scratch, right, is like that, okay? Use a list. Now these members, right, okay, save it as a list, put it here. Use this command called pandas dot series. Save the outcome to a variable. This variable will become a pandas series object and carries the properties of pandas series, right? So if you double check, right, the data type is definitely a pandas series, See, and then if you check how many functions you can apply on it, it's actually a lot. Oops. So if I use a dot, right, by a tab, it will have to wait a while. It has a lot of functions. See, you see how long the range of function you can use on the pandas series. Okay, lots and lots of functions. I don't know most of it. I know what some of it might do, but I don't know most of it because there are too much, right? All I have to do is to remember a few good ones, right? especially you use it for your machine learning work. And anything else you're not too sure, but I think maybe there's a way to do it. Just Google, Google the phrase it, the question such that someone will show you how to do it with pandas. Okay, so there you go, right? Then this is how to create a series, right? I think here also another way, using a dictionary. When you use a dictionary to create a new series object, the dictionary keys, right, become your index number or your index key. This is your data. Okay, so if I run this, right, you notice the slight difference between these two. Here we simply just give them the data, right, using a list. So the index number is auto-generated, right, provide automatically. But here we explicitly say that this is my index key, using the dictionary way to conduct the conversion, right? So this is a pandas series, but index key is provided by you, customized. So you can also do that if you want to, although not necessary in most cases, right? Then can we assign a column as index? Actually can, good question, but not on series. Because series after you're working with only one column of data, right? You're talking about in aspect of pandas. You're thinking of pandas, right? I said thinking of data frame, right? So say for example, early on we have I don't know whether this is taught, but I think it's not. Okay, let me come back to this. So let's say I want to turn the employer ID into my index, right? Which makes sense. Sometimes we do that, especially we know that this column here is unique, right? Which we know is 1,000 rows of unique values. Makes sense to turn it into an index, have more meaning to access it. Then all you do is to I think the command is set index, So then what you can do is I try to remember, I think it's set index. Let me try to bring it out. Okay, there you go. Using a set index function, you must mention which column to become the index. Okay, so I think it's like that, I'm very rusty about this, I think I need to, wait, I think I just need to mention the name. So it should be employee ID. I think this is good enough. There you go. See, the outcome of this simple set index function, right, will use this column called employee ID, turn it into the index key. You see, no longer 0, 1, 2, 3, 4. It's now just now that column, and column gone. Column is no longer part of the data. It actually has a name. Yeah? This is the name of the column some more. Name of the index column. When you say give the series a name, you're talking about, because this is data frame. He's asking whether can assign a column to index. I'm answering that. So I don't understand your references here, JY. Can you explain? Okay, but you're providing a name. Is that what? Is that your question? You want to have a name literally, Where's the part? I don't see that question anywhere. Anna, can you let us know? Is that what you're asking? Is it Anand or Miss Ran? Anand, right? Anand, is that what you're asking? Are you on mute? Can you share with me what was your question?
What you explained is correct.
Huh?
What you explained.
Oh, you wonder what I want to do, right? Okay.
Yes.
Okay.
Yes.
So
this is the one. This
okay.
is correct.
This makes sense, right?
Yes,
Because you know that this is unique values, right? Makes sense to turn it into index. We do that. That's why there's a function to do that. You can do it this way. Okay, so I put this in the what also, So I thought this is what you wanted. But what your friend suggested that also is an interesting thing to do. We can give a column name a name, through that technique he just mentioned. Not something you do very often, because like I say, we don't use series directly most of the time. So, but you can do that if you want to, right? Giving the column a name, okay? Because series normally the column doesn't have a name by default. Okay, now I have to add on a little bit, since I think we still have time. Most of the function in pandas, right, when you do something like this, it gives you the outcome, but it did not permanently change your data frame. Okay, your data frame did not become this. This is just the outcome of this action. Let me explain. If I now check the first few lines again. You see, it did not change. You notice that? So if you want it to be permanent change, right? There are two ways to achieve it. It's actually mentioned further down, but sorry, give you the idea how to do it in most instances, because like set index, like maybe what else? Fill NA, commands like that. There are other commands that maybe end up doing things that give a change to the outcome. You can always make it a permanent. Right now it doesn't, right? So two ways to do it. One is you use df equal back to it. This will force it to take over this outcome. Your current data frame will be updated to this. This one way. Another way is use the in place parameter. Okay, most of the pandas data frame commands has the option of in place somewhere there. If it's meant to give you a permanent change, set to true. Either of this method will achieve the same thing. The current data frame will be updated based on this outcome. Okay, if you want a permanent change, use one of them. Okay, so I'll place both inside the code share. So to make permanent change to df. Okay, so but you don't use both, you only need one. Okay, so choosing which method is up to you. All these are choices. Right, just like any other things you learn so far from Python, you realize that there are a lot, sometimes there are multiple ways to achieve the same result. So this is one of those instances. Either one is good enough. Okay, this will make permanent change. So I'm not going to run it. I'm going to leave it as it is. Okay, so let me go further down. Here, okay. Oh, here is about the indexing, right? Okay, I'll come back to this. Let's see what else I need to cover. Okay, I'll come back to indexing shortly. I'll come back to this. So here now talk about creation of data frame. Again, you can still use in fact, data frame usually you will use a lot of dictionary to do that, because you have two dimension. So in this case, to create a data frame from scratch, you can use a list of dictionaries items, right, to generate your data frame. This is one way of doing it. Okay, whereby if you use a list like that, right, each of these information is based on a column. Notice that your column name is here, the key, second column. So the positioning, right, all matters. This is your third column, right? Column name is here. So you run this. This is one way to generate something from scratch to become a data frame. And notice this, you exactly have three rows of three different columns of data. Automatically, there's an index number 012, and you pick up these keys as your column header. Okay, and okay, this is to read a file as what I did earlier on. So remember, you have another file called this .csv, right? So you read the file and you can easily check the first 5 lines. .head is very handy. It's an idea that's borrowed from Unix, whereby Unix you can check head or tail of any, I think text file to see the first few lines, right? So this technically read this file. Then next thing you just check the first 5 lines. This is the default. You can check more lines if you want to. You can check lesser line, right? Oh wait, I haven't read the file here. Okay. Oh, okay. So you can add some number inside here. Maybe I just want to see 2 lines. I want to see 10. Now you can control. But usually 5 lines is enough. The idea is to use it to have an overview as a feel what you might be working with. So .head is very useful here. That's why I always start with .head, .info, .describe, because it's going to be useful for me to understand what I'm working with. Okay, so now I'm going to show you about all this. So okay, this is good to start to learn now. Okay, I'll show you about all this. Okay, after all this, I think we just learned a bit about this. I think you cover most of the things already. Okay, come. Now, I'll think I squeeze in somewhere here. Okay, nevertheless, I'll be copying things into the code share. Okay, when it comes to pandas, right? Pandas data frame, it also kind of follow the convention of your indexing. sizing technique that we have learned so far, right? To access the different portion of the data you have here. It does do that, So maybe I'll use what we have here, Okay, let's see what we have. Let's see how big this data is. Okay, 57. Okay. So small only. Oh, this file is so small. Okay, small is still workable. Okay, so it's only 5 rows, 7 columns. Okay, fine, we work with that. Okay, so in general, it actually follow the same concept, but it has its own ways to extract specific range of data. So I'll show you how pandas work on its own. For example, you have already seen one way I did it. How to get a column? You just need to use a square bracket again, right? But you just mentioned the name of the column. Let's say, for example, I'm interested in the class type, right? Just type the name of the column. Case sensitive, spelling must be correct. And there you go. So I managed to extract exactly just one column of data, which in itself is a series object, right? Sorry. We check the data type, right? It is a series. So this is one way pandas can make life easy for us because we have this to reference. You don't have such thing in NumPy. You don't have such thing in list, and no tuple and all that. Dictionary come close to it, but dictionary, all those things are just merely index key, right? With pandas, you have the capability of just mentioning the column header. You extract all the whole column out. Then you can do something about it, right? So I say I extract something that's numbers, right? Let's say for example students, Okay, I go one step further before I come back to the indexing and sizing, right? Because I extract the whole column, right? Now here can behave like what I did with NumPy also. I can do things. I can add numbers. I can do some mathematical calculation. See the increase. Or I can multiply. Or I can even divide if I want to. You see, you can work on it mathematically by the whole column, just like what we did with NumPy, but it's even easier. True, right? Can even check comparison, like whether are they greater than, what are the main numbers? Oh, so small. Yeah, maybe check whether they're greater than 10, You see, you'll come back true or false, right? Oh, mostly true. I'll make it be maybe 35. What numbers do I have? Oh, so small number range. Okay, maybe like that. Okay, so you got some false, some true. So you see, this concept also very similar to NumPy, but I think this is easier to understand. By the whole column, right? In fact, you can do by any range. I'm just showing the fundamental possibility of it. Okay, so let me copy this first. I put in the code share. You can try out. You can do things like that. Without it, it's simply one whole column. Then this is one way, right? You can extract per column, but a more a more comprehensive way to access anything you want here is through the two different way of method. One is called .log. The other one is called ilog. I represent index key, right? We'll skip that for now. I'll show .log first. .log is easier to use. So .log will require two parts to it. Just like earlier when we learned NumPy, this is a row, this is a column. So row we base heavily on the index key number here. So right now it's 0, 1, 2, 3, right? So I use this. Earlier when we play around with this one, I could have used this as a key. So in this case, I'm using the default one. Okay. So I say I'm interested in this value here. So I'll say .log square bracket 0 for the row number for the index key here. Then class ID, right? I'll use the class ID as my reference for the column part. And there you go. This function like an index, the way we did with NumPy or anything equivalent. Okay, so they give you the first value here. Okay. Then what if I want to grab something like here, right? It will be very easier. Row number 3 for the key, index key, and the column is rating. So you can still do the same. Just make sure you identify the correct row index and the correct column header. Right. There you go. Now I got no. So it's that straightforward. It's exactly like that. Okay. Now, if I now want to have some fun with it, right? I want more. I'm curious about maybe all the information for, okay, maybe not all. Let's try, let's keep it simple. I'm interested in the first two rows and the first two columns. So only 1, 2, DS101, 102. Okay, that's why I'm going for these two and these two. Huh? So how do I achieve that? It's how to set the range. So the sizing is where it going to be crazy a little bit. Huh? Sizing with pandas, sadly don't follow the same convention rules that we learned so far. So I'll explain that. Let's make sure we can get this part off. So this is 0 and 1, right? Okay, 0 and 1. Okay, I don't know whether you realize something is not right already. Okay, and this is class ID and class type, right? Okay, class ID. Okay, got underscore or ID. Class type. Class type. Okay, hope no spelling mistake. Now, notice, I managed to get the 2 by 2 that I wanted, but anyone can spot the subtle difference from how we normally do something like that, even with the numpy we just done earlier on. Where's the subtle difference? Anyone can spot that? Kudos to you if you get that. Yeah, well done, Wenshi, huh? Notice what I did. I choose a stopping position, right? Exactly these two, and the data is included. Very different from how you learn sizing. Very different from just now when we learn about numpy, right? Numpy, when we do this, it will not be included, isn't it? Oh, starting position, yes, that one is given, right? But stopping position, it will never be included when you do the normal sizing with list, string, or in this case, numpy also. But for pandas data frame is allowed. It is inclusive. It will include. So both rows and columns behave this way. Dot log is like that. No, JY is correct, but I'm going to that. You're ahead of everyone else. Okay. Let me share this out with them slowly. Okay. So, Jianwen, where is it? It's right here. When you run from this one, then you must run this. I'll run this first. Under data set, just run this. You import this file. That's why I suggest put all the file together nicely. Run this cell, you can bring the data in. Okay. So now, so you see the problem is that when you use a dot log, right? You have to be very careful here. It's the only one time when we use this kind of sizing technique, right? The stopping position will include the value. Must remember this by heart. Okay, this is very painful for us because when we learn Python, right, we learn by heart already that stopping don't include, right? But now you must remember for pandas it does, especially when you use dot log. Okay, I'll come to dot ilog later, which again behave more traditionally but different from this. Okay, so it's very, very painful when you do things like that. But it is given. Pandas work this way. So just remember, start, of course, is reasonable, but stopping position, right, will include the value. Okay, will include value. Same thing even on the column level, right? So that's why I can use it this way to get exactly this, and this. Okay. So let's say I want to try out something like maybe I want to get this last tree, right? I have to pinpoint exactly starting from here, ending here, and starting from here, ending here. Okay. So let me try it here before I copy. Maybe first I copy a few things first. Okay. I hope this is clear for you. And maybe I put this inside the code share. Since some of you might miss it. Okay. So do another example to understand the how the dot log works in general. Before I do some variation on it. Yeah, I think I still have enough time. Okay. Okay, so let's say I want 2, 3, 4, right? So 2:4, and then what's that? This one is instructor, students. Okay, so let me bring it down. Right. Okay. There you go. So now I managed to get index row 1, 2, 3, 4. With respect to the column data instructor rating students. You see, you can do it this way. Just remember the stopping position will be included. Very different from what we understand so far. Huh? Very different. Huh? Do we need to reset index after splice? You mean slicing lah? Why do you need to reset? Oh, you're talking about just now when you did the setting index. Resetting is to let me see. If you have done something like this, technically you do not need to reset. Reset, you are actually setting your index all over again. No, you wouldn't want to do that. Huh? That's a very different command. Huh? You wouldn't want to do that in general. Okay. Now, back here, right? In fact, because it still sometimes follows certain slicing rules, such that, let's say, for example, right, I may be interested in from anything here all the way to the last row. I can then say, remember the default setting, that one still set. So let's say I do this lock starting from, say, index row 1. Then I can use colon and leave it blank, and followed by maybe I want everything from the first column all the way to co-instructor. I can leave the first part blank, but where I end is co-instructor. Instructor. Then there you go. So default setting still apply. Or even though the basic answer on where you stop, whether inclusive or not, that part, that's the only thing that's different. Everything else, like the default start, default end, right? All this remains the same, right? So now I start from 1, ends at the last row. Last row turn up. Start at from the beginning. So start from beginning, and at the co-instructor. So see, you can still do things like that. Okay, so this part still managed to behave the same, right? The only key difference is stopping position will include the value. Oh, sorry, I should put it in the wrong place. Okay, okay, now hopefully this part is still okay up to here, right? Let me see. Well, anything else I have to show? You can still even go one step further. Let's say, for example, right? Remember, when you do slicing technique, right? You can do what you call that? The number of steps. So say I will see everything, right? Starting, ending, and I maybe skip by 2. You can do things like that. Okay. So in this case, right? Default starting from the first row, default ending the last row, and I use one more colon, right, to skip each time visit the next second row. The step still apply. This one still apply, okay. Then this one I just simply say every column. So this one still apply, So most of the sizing technique you learn so far, right, applies, except that one difference I keep stressing so far, right? Okay, so let me see, anything else we can try. Okay, I think this is enough before I jump into the iLog. Any questions so far? Hope it doesn't mess you up too much. Okay, now the interesting thing is that with pandas, right, they offer you 2 different ways to size your data, right? One is using the dot log method, which normally is the go-to, because it uses what you see here. Okay. However, with pandas data frame, right? Let me use back this guy. The what you see here is what is keep track of the I do not know the best way to call it, the name given for the column, and kind of the I guess the name given for the index value for the row. Effectively, in the background, there is another set of numbers, right, or row and column index number that keep track of the actual index numbers and the actual column numbers. So in the back end, there is another set of values keeping track of it, which it doesn't get shown directly here. So for the row, by default, it's also 0, 1, 2, 3, 4, same as this one. Even if you change this with the kind of index setting we did just now, right? The original 0, 1, 2, 3, 4 stays, right? In the back end, the number's always there. Then here on the column level, right, also has an index number that track it. So there's a column index level 2. So there's a row index number. There's also a column index number starting with 0, 1, 2, 3, 4, 5. So you can use the I guess the index numbers, right, for the row and column as a way to navigate and choose what you want also. Hence, instead of using .log, you can also use .ilog to do it. That's why the I kind of remind you that it's using the true index key values of both for the row and the column. Now, let me illustrate so that it's clear. So you can do it this way. Use .ilog. Okay, still using square bracket, still using comma to separate the rows and columns. But this time I'm dealing purely with numbers already. So if I use the row index number, right, which happens to be the same as the display version, so this part more or less the same thing. It's here that will differ. Let's say, for example, I want this thing, this 4 again, right? So I will use same thing, 0, colon, here is here where it differ. Okay, I'm going to put the correct answer first. Later I explain. Then I want these two columns, right? So class ID is at 0, colon, and up to class type, right? But I have to put 2 also. In this way, I get my correct answer as before. But because I'm using the true index position key numbers, I have to follow back the golden rules. The stopping index is not included. This is based on what we understand so far. Okay, when you use .ilog, we follow the rules of the how we treat the stopping index. It will not include the values, and the column also has its own column index number. So this technically is the same. It's the same as just now. Where were we? Somewhere here. It's the same as this. It's the same. So maybe I put together. Okay, I'll do the same on our on our code share. This will be the same somewhere here. Okay. So it gives you again choices. You can use .log to achieve this. You can use .ilog to achieve this. But you must realize this is different from this. This is different from this. There's a set of index number that govern this. Okay, especially these two. This and this is actually two different set of values. So because it's treating it literally as an index key numbers, the stopping index sizing technique will follow the same rules that we learned about list, tuple, string, and numpy. So stopping index will not be included. So you have to define it this way clearly. Okay. Other than that, everything else is the same. Like even the default value side, if you don't put anything here, it will also start from the beginning. If you don't put anything here, it will definitely end at the end. Things like that. And then if you add something more with the step, right, also behave the same. One will be the default. 2 will skip to the second one, the fourth one, things like that. All this remains unchanged. Just that when it's .ilog, you're dealing purely with numeric index number on the row and on the column. Okay, so let's say I apply the same for this one, right? Then it will be slightly different in terms of the how you end the number, right? So let me try again. So for .ilog, this one definitely will increase by 1 more. And of course, instructor is where? Instructor 0, 1, 2, 3, 4. Okay, start from 4, right? Start from 4. And 4, 5, 6, 7. So I need to go out of range to make it work, right? Let me see. Okay. Oh, here. Okay, sorry. Why am I touching this? Hold on. Was I looking at? Let me see. This is done. Oh yeah, I am at the right place. Okay. Let me go back. Okay, 4, 5, 6, 7, right? Oh, I accidentally touched this. Okay, I don't want to mess up. Oh, I don't bother. Okay, never mind. I meant to change here, right? So let me copy this one over here first. Okay, undo this. Okay, so this is the original one, right? Let me make sure nothing changed. Okay, this is the one using .ilog. So I better put the I here. Okay. So these two will give you the same result also. By using index position number, right? One for the row, one for the column. Okay, I hope it kind of makes sense to you. It might sound very confusing because they use two different systems to do the same thing. So again, it's up to you or choices. Most of us will stick to this. Occasionally, then we end up using this if the need is there, right? I only use this if the need is there. If not, this is good enough. Just remember the stopping index will include. This one, no. Okay, so the rest will be the same. All the default settings still behave the same. So how come I got one here? Interesting. Okay, interesting. Okay, so all this will still behave the same, right? Even I switch to the .ilog, the default setting is always the same as intended. Okay, so I let you try this out on your own, okay? Then I plugged that in already. Let me see what else. I think okay, I'm good. Okay, I pause here for now. Before I go into something more, I will show you something more that only pandas can do. Well, not really. About only pandas can do because there's a column name. Now, any questions so far up to here? How to use .log, right, to get a particular value or a range of values, right? And how to use .ilog to more or less do the same thing. I hope this is clear with the demonstration. Okay, if no question, right? Now, let's see. Let's mostly cover some of the things I mentioned. The .ilog is here. I want to some of the manipulation I mentioned earlier on. I like to okay, I'll be talking about something like this shortly. Sorting is fine. Okay, I'll show you. I'm surprised we didn't do that. Let me see. These are merging. Merging should be not an issue. I want to show you. Okay, I want to show you this eventually. Okay, maybe I'm a bit behind already. Okay, let me see what we have. Okay, once I reach there, I'll continue. Now, so far what I have covered is about up to all this I covered already, right? In essence, same thing for all this. Then manipulation to some extent I covered it. So just like NumPy, you can do any mathematical operation. Very straightforward. Now you can do stuff like that. No, is this the one? Okay, you can in essence, pandas you can do things like that, which is very cool. You can pull out the entire column, right? This gives you a series and perform mathematical operation with another column. So here's turned out that we do it with the same column, but this could be a different column, or maybe, for example, you have a panda data frame that has a column that keeps track of length, width, and then you want to maybe calculate the area. Then you can length times width. Then the result will be every row, right, will be the answer of that particular row for all the respective length column and width column to do the multiplication. You can do that. Or the outcome then can save it somewhere else. Okay, and in fact, what you might do actually, normally you might do things like that, right? You perform the column extraction, right? And perform some mathematical calculation with another column. In this case, just the same one. The outcome is a column on its own or the pandas series on its own. You can reassign to a brand new column name or brand new column inside your data frame. This is allowed. With pandas, you can do things like that. So it's very frequent. This is how we kind of transform data from one to another, which went through some form of basic, maybe mathematical operation. Okay, so in this case, we are simply adding the student values from each row, right, back to itself. Outcome will be a series of rows of the sum. We create a new column inside the original data frame, and then you see it shows up here. So it adds itself, right? So 40 plus 40 give 80, right? Then the first row is the correct answer. Sometimes 2, right? Same thing. So it's very powerful ways to easily transform data. Okay, so it's very common things that we sometimes also do, right? Can easily add one more new column just like that. As a matter of fact, let me run this first. I think I have it already. Okay, I can even override or supersede the existing column with some values. There are a lot of ways to do that, right? For example, now that I know I have this column, right? Okay, let's double check. Okay, this column exists in the current file, right? I can one shot replace it all with some value, some default value, just like that, a simple equal. Okay, then if I double check, it has been updated. See, one simple assignment I assign for all the rows. And do you realize something else? I kind of change the value directly. Okay, so you can do that. This assignment technique, right, on a row name, on a column name, can be done on existing one to change the value to something else. One shot all the rows in that column, or literally create a brand new column if it doesn't exist. One shot with any values you want to put here. I could also put a 0 here, or not necessarily must do a calculation, right? Or just to assign a new column with some outcome, right? Doing calculation give you a dynamic answer, or even here also can, but assigning a fixed value also can. If you want to provide some fixed static constant assignment, right? Pandas let you do either one of these. Okay, so try out your end to see the differences. Try things. Try out. Okay. Then that's one. Now, once in a while you might do some sort of sorting. Not meant to purposely change it, but more to. Oh wait, my code share something went wrong. Hold on. Okay, sure it died on me. Okay, hold on. Is this a code share? Yeah, okay, I'm at the right place. Sorry, somehow my code share died. Okay, so once in a while you might like to sort your data frame or even a series. You can use a sort values to do the trick. You just need to mention by which column, and maybe with or without mentioning whether you are doing ascending or descending. And when you run this command, your original data frame, right, the order will change based on the sorting key, in this case by students. So it's here, and depending on whether it's in numerical or alphabetical, you'll sort accordingly. It's clever enough to figure out what should you be doing, like small to large number, or lower A to Z kind of thing. Okay, so you can sort it this way, right? And if actually you might not need to if you don't mention this part, right, the default should be ascending. So ascending will be default to true. Or if you prefer to go by descending, like what we did here, you must set this to false. Right? If you leave it alone, right, or set to true, that will be ascending order. And then here, you can have one or multiple sorting order if you want to. The first one will be the first priority, first level, then second, third, fourth. If you use a list. Okay. So in this case, you can go for more complex arrangement if you want to. So let me run, make sure it works. Okay. So let's say I want to control by, I don't know whether it makes sense. Maybe I can use these guys. Okay, so what I can do is that I can sort by this level first, alphabetical, then by the students, by the coordinating TA, right? Then by the students. So I need to use a list for multiple key sorting, right? So student will be second level for me. First level should be a coordinating TA. Oops, should go after that. Okay, let me take away this one first. So if I don't mention anything, default it should be always ascending. Right, there you go. You sort A, B, C, D, this one first because this came first. Then for the same one, it's sort by numbers now. Also ascending order, you see? So if I want to control the individual ascending or descending, right, also can. So now you must put back the ascending. Also use a list to individually control which one sort ascending or which one sort descending. False is descending, right? Yes, right. It should not be the string. Should be true and false only. There you go. Okay. So this is the most complex way of doing it, but it's possible. I put it in the code share. Okay, I'm going to code share again. Okay. So I think you can try out your own or various different variation, right? Okay. Now remember this, I ran this earlier on as one of the first few things I would do. So it's good to have a good idea, especially all the numerical columns, right? What kind of distribution you might be working with. to identify whether there might be any sign of outlier possibility, right? So when you do a describe, it will show you descriptive statistics of all your numerical column, right? Category cannot do that, right? Numerical column. So it will show you very important, right? The averages, standard deviation, and the quartiles information, is 0%, 0 percentile, 25th, 50 percentile is your median, right? 75 and max, So normally how I use this is that if I see, this kind of values, right? Especially here against here, it's very spread far apart, like very huge difference in terms of the scale of the number. Like for example, this is 3, right? Let's say this is like 5,000. Oh, very big difference, okay? So probably it's very skewed to very small numbers. And that means the other side that extend to very large number, right, take up the rest of the percentile. That might suggest there might be outliers there. Or that's a sign that suggests that, or maybe the other way around, right? Let's say I use these numbers. So the 50 percentile is here, then 75th max, these numbers are pretty close. Then suddenly somewhere around the smallest values of maybe 25th percentile, or it's a super small value, or like maybe 1, then here maybe 2, then here then jump to these kind of values. It seems that it's skewed mostly to the higher end of it. Then all the small values take up a lot of wide spread away, then that might suggest here may contain some sign of outliers, things like that. I watch out for stuff like that, Then other things might be useful to give you an indication, also how far apart the median might be from the mean, also a sign of whether it's skewing too far away, also another little sign to indicate there might be outliers or not, also compare mean and median sometime. Right, so this is handy for that kind of quick idea or quick overview, before you even start using visualization to like using box plot to figure that out, right? That is something you will learn later on, using visualization to further confirm your suspicion. Okay, with numbers, this is how I tell. Okay, so dots describe is very handy for that, Okay, let's see. Okay, dot concat is something we use once in a blue moon if you are trying to combine things. If you use it as it is, right? As it is, actually it's quite silly that we use back the same, but never mind. I'll just use the example that's given. So dot concat is very handy to combine two data frame. If you don't use any extra parameters, you will actually do an append, which means that all the rows from here will continue from all the rows from here. You are doing appending, but dot concat also can do kind of merging, right? It means all the same rows from here, all the columns will combine with all the columns from here. That's merging, which you also can use dot concat to do it, right? Sometimes we do that also, but in general, if you don't put any extra parameter here, then dot concat itself is kind of a dot append kind of command, So for example, right, this file has only like 5 rows, right, The 5 rows were this. So what we did here is we concat it back to itself, so we read 2 times, right? Each time we read, we create a new data frame. So these are two separate data frame objects, but we purposely concat them together so that the rows here will continue directly from the rows here, right? And to use dot concat, you have to use a square bracket as a list to mention the multiple data frames you're trying to concat into one, right? So normally this one you probably save it as another data frame, maybe combine, Normally you do it this way, combine df, right? Maybe you put them together, assign it back to a new variable, then this is your brand new data frame to continue working, and it has the contents that looks like that. If two now do not have the still can, then you have something interesting, the columns that one of them don't have will have null values. You have missing values. Okay, sometimes you might end up things like that, then you have to figure out how to handle missing values. Okay, so yes, good question. It's possible, It's very common in real life example. Okay, so dot concat normally I use it for either this or to combine them side by side to add more columns. It's possible that, say for example, it's a totally different file. It may have similar number of rows, but it has different column values. I like to combine them side by side, right? I want to add the columns from here to the first file on the side here. So you still use this, but you change the orientation, huh? So if I remember correctly, it should be axis. You use something like that to indicate that you are combining it with more columns. Without this default, you are combining them with all the rows by rows this way, which is a default choice. Okay. So yeah, that's where we use .concat the most. Once in a while, you might do that, right? If you have maybe data file, right, that is so large, right, they split into multiple files, but because you need to analyze all of them together, right, then you need to use .concat to help you with that. You read all the files one by one, right? Then use .concat to combine them all up. Okay, sometimes you do that. Okay. I think practice, I'll leave it to you. They actually give you these two. No wonder they use. Okay, this is something for practice. So you can try out. I leave that to you to try out. Here is what? Create a new. Okay. This is the idea of using the technique we learned just now, right? Create a new column by giving a new name, and followed by what is the information you want to provide. In this case, multiply this current column with 2 for all the rows and assign to the new column. So this is an exercise for you. You can give it a try. This one is more or less the same idea, but instead of plus or whatever, you just multiply some values here. Okay. This is a dot describe statistics, so nothing special. Okay, this one is interesting. Technically not exactly shifting columns, but the final outcome does give you an illusion that you did shift the column around. So what truly happens is this. I did mention this just now. So say for example, I have to use the all lines. That means I must run more of this. Let me run that one line that settled there. Okay, must run this one. Okay, must purposely create the all lines CF. Okay, run this so that you combine these two together first. Okay, then let me go all the way to here. Okay, here. Let me add one more. Let's double check. All lines. DF. Okay, good. So okay, what here is trying to do is that currently the position of your column is like that, right? It claimed that it shifted it around such that price come first. Then how come it has I need to run one more thing. I think this one, in order to purposely generate this. Okay, let me run this. Okay, let me now double check. Okay, good. So what it's trying to do here is to suggest that you can rearrange it such that price comes first, followed by SGD dollar conversion, followed by country, and even drop points, right? So it actually swap the position around using this, which you're allowed. So fundamentally, right, remember we learned about some basic ideas just now. If I want to extract just a column, you do this, right? Let's say price. But if you use a list inside here, right? Technically, as long as you use a list to represent the columns you want to use, you are setting up to return a data frame. Like for example, the one I just ran, right? It returns you this. This is a series. Remember, I keep talking about that, returning a column out of data frame, always a series. But if you use a list of column names inside this square bracket, right, this gives you a totally different effect. This will give you a data frame result. It will never give you back a series. Look at that. It's a data frame. You see, I even look and feel a data frame because it is. It's multiple rows of data with a single column. This is still a data frame. Just one column. Right. Let me affirm that it's the case. Look at data type. It's a data frame. Right. The difference is the extra square bracket inside representing the list. See, originally it was just a series. One column, one dimensional object from pandas. With a square bracket to create a list inside, you now definitely return a two-dimensional data frame object. Now, because you can do this, right? Then what you can do is that you can change any position of your column inside a data frame based on how you place it in the list. So you have one price come first, followed by SGD and country. I place exactly in that order inside my list. all the while inside the list. Right, I use the list to keep track of the order. So price come first, SGG, country, then it will display the data frame exactly in that order. You see? This is what happens here, right? We did shift it around. We kind of rearrange it through the trick of using a list. Then if you like this, then you can just save it back to the original one, which is what we just did, reassign back to it. So it gives you the illusion that you have reordered the columns. Okay, so it's just a clever little trick with pandas where you can do so, or because we use a list here. Okay, so this example is already here, so I won't add anything more, Okay, so so fast. Okay, filtering. Filtering is very important. I hope I can cover this quickly. Let me see anything else important after that. It's in is okay lah. Likely we will be able to do that. Okay, the filtering part is one of the last super important things that you should know how to use in pandas, right? Because it really helps you to further extend the kind of way you can determine exactly what data you want to work with. So the very classic way of doing things like what we do so far is, I say, for example, this guy using a feedback. These are the data that's in feedback, right? And under the class column, exactly this, right? In fact, there are two types only, DS101, DS102, right? You can kind of identify which row is 101, which row is 102 by using comparison, So you can equal. Let's say I'm interested only the 101, right? So it's a string, DS101. Then it will give you a data series, a panda series of true and false statement. Kind of similar to what we learned earlier on with NumPy, right? This part is similar. So true, true, false, false, true, right? So obviously these two are not DS101. With this, now I can reduce this, right, to only the rows that is true. How to do that? We use this series of true, false, right, inside the indexing sizing technique again. So like that. You put a square bracket around the whole thing. In other words, you use the outcome of the true, false values in a panda series, apply back into indexing technique for the whole panda data frame. This will force it to only show the rows that is true. All the other rows that is false, it won't show up. It will reduce just the rows that meet this condition. Pretty cool, right? So if I run this, see, only row 014 comes up because they are the class type of 101. Right? Alternatively, I can say I don't want to see 101. Anything else but 101? Okay, so a very different condition, right? So the rest will show up. So this is pretty cool. Let's say what else we can do with it? Feedback. Let's say like using numbers, right? I say I only want those that are equal or greater than maybe 43. So I can even do that, right? So I can say wait, smaller than equal to 43, but I need to choose the correct column. So I can say students. Right? So students number that's should be greater or equal to 43. That will mean this one, and this one, right? And I use it within the indexing technique here, right? Like that. I will draw only the rows of those that met this condition. So you see how you use a whole column to do some conditional check. The outcome is true and false statement, right? Only the true will show up, false won't. So you apply back directly in the indexing technique here. This is how you can extract only data that satisfy very fine-tuned condition setting. Also fine-tune that you can will do multiple. Okay, so maybe I'll put this one in the code share. This is something I think not inside the one. So if I want multiple condition, right, then you have to be clear what you're trying to do. Multiple condition has certain things you need to be clear. First, you must have some bracket around each of the condition. Okay, then I'm going to try a second one, right? For those that are these values, I'm only interested for maybe 101. So two condition, right? And to do two condition, most of the time with pandas, with Python, you use AND statement, right? with this one inside the indexing technique, you must use this one, huh? You must use this to represent n. This one to represent all, huh? Okay, so let me try with the n, huh? And usually safer to use a bracket for every condition. So I'm going to check what class type must be 101, right? So don't forget to use the whole column. df class type equal to DS101. Okay, so I use a more complex condition setting, huh? Whereby firstly, students must be greater or equal to 43, and also at the same time, class type must be 101, huh? So that's you take away number 3, right? There you go. Okay, this is a bit more complex, huh? Let's try the or, let's try alternate. Let's try alternate whereby maybe something that kind of makes sense. Maybe I try rating, huh? Okay, so I will list out all the rows that are when the student is greater or equal to 43, or right, or if we specify also, no, maybe ratings, right? Oh, ratings got new and low, huh? Okay, oh, that is not good. This is bad. This data needs to be cleaner because mathematically I cannot do this, huh? I will use something else. Okay, I use back this one, huh? Or I think it's going to or class time is 101, huh? Okay, so now I use an or statement, right? Meaning that if this one satisfied, whatever outcome is this, I will still show that row. Or if this one satisfied, right? Whatever this outcome, it doesn't matter, I will still show the row, right? That's how the or works, huh? So now I see what's happening. Oh, almost everyone turns up, huh? Because for this case, they are 101, right? So all the 101 will show up. Then for others, one of them, which is not 101, but the value is still greater than 43, it also show up because I use the or statement. Okay, so you can combine respectively depending on the fine-tuned conditions setting out to do. You want to display all columns with column name contains student. Do I use filter? Wait, you want to column name? You're talking about column name. So you're talking about this one and this one. So I say, okay, this one is very interesting. Then you have to use this little trick. Column names happens to have a way to bring out. There's an attribute for it, huh? You can use this little attribute to bring out all the column names. Then you play with this one. Okay, it's a very complex trick, but I think can be done, huh? Firstly, you know that now you can bring it all out, right? Then next thing is probably, let me see what's the best thing. I can use a list. In other words, I can use a list, then a list generator, then I can throw back in. I could. Hey, what do you want to show? All the column. Oh, yeah, I want to show all the columns. I can do that way. I can use I use a list first. Okay. It's quite interesting that you want to try this, but yeah, why not? It's possible. Okay, turn in a list first, right? Then maybe do I overthink it? Yeah, I'll use this compression. Okay, so student maybe each list, each item, each column in this. No, if each column, oh yeah, correct. Each column equal to not equal. You're talking about must have students. What's the best way to find a word inside a string? Anyone remember? Just need that. Right. Let's say one contains. Okay, thank you. Well, you're very good at remember this. Well done. I always have to search. Okay, let's see where I get it. Okay, I must have made a mistake somewhere. Embedded syntax. Where did I go wrong? It's in. Each column is a string, right? Each column is a string. So where did I go wrong? It's already a string. Yeah, agree. So you're saying I use in better, instead of contains. Okay, then I tell you they were. I thought contains will do the same job. I always forget. Okay lah, in will do. Each wait Okay, it's good. So each column sounds fine. No, still some syntax. Where did I go wrong? Okay, do a simple check. Students in, what is that? Student double. Okay, it should work. Where did I go wrong? Actually, it works, huh? So I don't know why I have an error unless my disk compression went haywire. If students in each column, unless this is not a string. It's possible it's not a string, huh? Okay, let's do without the if first, huh? Let's see what I can get. Because I made a mistake. My bad. For each column, I use the whole thing wrongly, huh? Totally my bad. Okay. Okay, now it should work. Oh, wait, still not right. Where did I go wrong? I made a mistake somewhere for each. Okay, this is correct now. Now put back here. It should be fine. Okay. If. Hell lot of mistake. Okay. So only if, but I still made a mistake, right? Because this is not what I want. So it should be this guy. It should be like that. Without this. There you go. Okay. So a simple list comprehension will get this. So maybe it will be best to keep it as a list, student column found, okay. Then I can now use it back in your feedback, since I know which column, right? So all I have to do is to column. So it should be a list, which already is a list, So I just say student column found. There you go. Okay. My friend, you give me challenge, no? And thanks to Mr. JY, or I don't know, is it Mr. or Miss JY? Thank you, for the assistant. Okay. So maybe I put together, It's a very complex one. I can't think of a slightly easier way, but I'm pretty sure there must be more efficient way. Programming is fun, right? Always someone can come up with a real more efficient way. So for me, my line of thought is very straightforward, very brute force one. I realized maybe this compression will work. Okay. So now, back here, where was I? Okay. So I already mentioned how to do something like that. So hopefully it's clear on how to use it effectively on the end, and you can further, always easily to choose exactly the data or the row you want to work with. Then you do some work on it, or maybe this is the data you need to extract. Now you got it, or maybe these are the data that you want to discard. You also found the index number for that, or maybe these are data you want to further transform to something else, right? So pandas let you able to do things like that, right? That's why we love pandas that much. It's very powerful doing this. You can't easily do things like that with NumPy or even basic stuff like list and dictionary. No way. Okay, you probably write a lot of code just to achieve something close to this one line statement. Pretty cool, Okay. So now, where was I? Let me see what else is important here. So most of this cover the things we just learned. You can easily set the condition as a variable name so that this part looks cleaner. Okay, so this is a choice to make the readability here. Then what else? Okay, this is an example about reading this file. This is about isIn. So isIn is just one easy way to check in this column. Any of them is one of these. This is where the isIn kick in. So you can use this to help you. So another way to reduce further to okay, this in here, keep it simple such that instead of writing whether this is equal to this and this is equal to this, and instead of writing that long statement, you can use the is in here, especially if you have a lot here to test. Then the is in is a like a time saver. Okay, so consider switching to this if you are testing a few different string values or numbers or something to test here. Okay, try out on your own now. Then I think that's pretty much it. I don't think. Okay, then dot sum, dot mean, all this exists. So far I didn't have time to show, but it's the same as NumPy. You can do dot sum, dot mean directly on each column. Okay, so in fact you can use it on the data frame entirely if you want to. So let's say this is employees. I don't think I read the file yet. Let me double check. Oops. Have I read the file? Oh, I haven't. Okay, let me read the file first. So let's run this part. I think it should work. Okay, so even if I use employees DF itself, right? I think I can dot sum anything with numbers, right? The column will sum up. Oh, I think I cannot. Okay, mistake. Okay, doesn't look well. Okay, better work on the column level, right? Okay, so I only have this one. Actually, I should be able to. Something went wrong. Okay, nevertheless, you can do this one, right? Annual. Oh, so on a series level, dot sum, right? You can do that. Oh, and then actually can I must have made a mistake just now. Yeah, can, but it won't look good because not all of them are numerical values. That's why I got some funny warning error, type problem, right? So best to isolate down to the only numerical columns, So dot sum, or even can do a dot mean, right? All this exists within the framework of pandas, you can do that, okay? So even mean also can, dot mean dot sum. Oh, did I spell something wrongly? Hold on, Is that, I made some mistake in the spelling, man. Strange. Oh, what am I doing? Not even thinking anymore. Annual income. Sorry, rushing. That's why I wasn't thinking straight. Okay, dot me. Of course you can. Okay, stuff like that. What else we have? All this is fine. Same thing with the condition. Too bad I don't get a chance to tell you this yet. Let me do a quick one. Okay, remember earlier I talked about is now, that kind of thing. I'll do a very quick one right here. Okay, so is now, is NA, give you the same result. Okay, always the same result. It's just two different ways to do the same thing. Most of us use is NA, shorter to type. Okay, now use the dot sum to figure out whether there are any missing values. Right? In this case, there are. Anyone with missing value, right, will flag as a row that's missing value, and then they will be true. Technically, if I didn't use the dot sum, right, you see true, false for all the columns. You see, anything that is false is technically equal to mathematically 0. Anything that's true, mathematically is 1. That's why you can do a dot sum for all the columns. So if all the columns are false under here, you will sum up to 0. False is always 0. But some of the prices obviously is missing, right? Because it's checking whether is it missing a value, is it a null, none kind of thing, then it will flag out as true. So there are 282 rows in this column, flag as true. So we can do a dot sum to see how many are there. So it's a very handy tool to figure out are there missing value in this data set. So if there are, then there are two main course of action you can choose. Either you can totally drop all the rows using a drop NA, so you can choose drop NA technique, right? Like this one. Sorry, here. Drop NA. Axis is always default to 0 row or 1 for column, but most of the time it's row. It makes sense, right? You go by row level to drop any row that has some missing value somewhere there, that row is gone. Okay, so you do a drop NA, the outcome will be a shorter data frame with rows that used to have some missing value somewhere there in one of the column. Those rows are removed. That's what drop NA means. So if you want to permanently update it, then you do this. Alternatively, remember I told you about the in place. Here is also have an in place. Okay, if you use it in place, you use it directly like that. Just put it in a line like that. It will automatically also update it. Right. So you don't use both together. It's either you use in place as it is, or if you want to reassign back, use it this way. Same reasoning as I showed you earlier. Then this is to the strategy of removing rows with missing value. But if you prefer to keep the rows, right, maybe you need other columns values to work with, then you must come up with a strategy to decide to how to replace the missing values with something. Here you need to have different strategy to work on it. The most simplest one is to give it a default value using your domain knowledge. So in this case, we assume that those rows in the columns that are missing value, I can fill it up with 0. So if you do it this way, then it will the outcome of it is that any rows that has missing values, right, or any column, any rows that missing value will equal to 0, or whatever to put here. Okay, this is the second strategy. This part is a bit tricky because you must put in something that makes sense. And not all cases you can do it this way. So in my line of work, right, most of the time I'll just go straight with drop. It'll be easier to work with, unless there are some reason that force me to make sure that maybe I keep the row as it is and try to use a respective strategy to replace the missing value with something that makes sense. There are easy 2-3 different ways to handle this, but I don't think I have enough time to cover in details. Okay. So that's what we normally do with missing values. I hope future lesson you might come across possibility to see how we do it with different strategy. Okay, so let me see what else we have here. Okay, I think that's pretty much it. Yeah, okay, cool. I'll pause here for now, right? Sorry that I overrun by 1 minute. Any quick question for me? Anything you'd like to further clarify? Things that so far we learned you're not too sure, feel free to ask me right now. I'll answer within 2-3 minutes. Anything else you guys like to clarify? Okay. In general, I hope everyone is able to pick up something new. Or maybe JY, you know most of this stuff. Oh, interesting. Good question. Most of the time, IBF, right, the video is meant for their own audit purposes. Likely they won't upload or share with you the playback. You can try. You can email them, see whether they offer that. But my understanding, normally all these are for their own consumption, for audit purposes. Yeah. Okay, beside that, any question from you guys? Anything you guys have control? For drop NA, how do we drop only null values under a certain column? Oh, under a certain column, I think if no, that doesn't make sense. See, the drop NA is designed to work with the whole data frame. If you drop just certain based on certain column, right, that means you're talking about within a certain, a certain series, no? That'll be very tricky. I'm not too sure subset will meet her requirement. Are you sure subset will work? We still okay. Do sign out in your what's that, the learning portal. Don't forget to sign up. You sure subset will work? Will it not delete how to put it, all the other rows as well? Okay, you can try that, You can try that. Okay, that's not something I try. I'm not too sure whether she's still referring to drop NA or not, Okay, but you can try. I'm not too sure whether it meet your requirement, right? You can try the subset. It's not something I'm too familiar with, Okay. So anything else? Any other question you guys like to answer? Okay, if not, then I think I'll have to end the class now, Thank you for joining me today. I hope you will enjoy the lesson 2 tomorrow, More about pandas. It's possible I cover some of the things tomorrow. Okay, have a good evening, Thank you for joining me today. Take care, and don't forget to sign out from the learning portal. Okay, have a good learning journey all the way, Have fun with machine learning. Okay, take care. No, Jianwen, I'm afraid no. Recording is only for audit purposes. Only audit purposes. But like I say, you can request, see whether they may allow you to have it. Okay, check it out. Okay, bye bye.